Oh,
Oh, lovely. The screen is really good.
You see.
Fascinating.
Yes, right.
Absolutely fascinating.
Awaj, Awaj.
Lighting of the lamp also. Very good.
Yeah, lighting of the lamp. Fire.
তাহলে এটা আমি ফলো করি স্পষ্টতাই বলে দিই বক্রতুণ্ড মহাকায় সূর্য কোটি সমপ্রভ নির্বিঘ্ন
Bas.
কুরুমে দেব সর্বকার্যেষু সর্বদা
Bas.
ওম
Good,
জয়
good, good, good. Organizer is, yeah.
Okay, good afternoon, everybody. We can start now.
Yeah.
1 minute before time. Okay. We welcome you all for today's online safety seminar. The subject of the seminar is Safety Overview in Various Engineering and Infrastructure Sectors, Present Status and Measures to Ensure Total Safety. This is an IIT Guwahati Technology Innovation Hub, TIDF and Industry Initiative to be delivered by IIT Guwahati faculty and acclaimed industry experts. Organizer and industry support partner, GBS Energy Private Limited. We have today eminent speakers from IIT Guwahati and industry experts from different fields: hydroelectric, shipping, steel, construction, mining, and all other sectors. At the outset, I would like to present a background of this program. On November 4, 2023, last year, subsequent to Sikkim disaster, we, IIT Guwahati, TIS, TIDF, and industry experts organized online workshop on natural calamity and disaster in Sikkim and West Bengal on Tista riverine belt, a relook at hydroelectric sector with challenges, opportunities, and roadmap towards mission hydro safety. Subsequently, we worked together in line with the same and taking it forward, the Center of Excellence on Mission Hydro Safety was formed early this year, 2024. Details of this aforesaid Center of Excellence will be presented by our anchor, Mr. Arnav Banerjee, Director Steel Tech, and thereafter we'll start deliverance of lectures. Over to Arnav.
Yeah. Good afternoon, everybody. On behalf of GBS Energy Private Limited, IIT Guwahati, and on my personal behalf, I welcome you all on this webinar. The Center of Excellence, the COE, IIT Guwahati Technology Innovation Hub under Technology Innovation Development Foundation and acclaimed industry experts, organized by industry support partner GBS Energy Private Limited. A dynamic ecosystem of innovation and development, an unique IIT industry initiative, where IIT and industry experts will work together for benefits of industries and society at large. Center of Excellence under Mission Hydro Safety will work in following areas for benefits of industries and society at large. Number 1, dam safety of existing hydro plants. Number 2, safety of new hydro projects, concept to commissioning. Number 3, renovation, modernization, upgradation, and life enhancement of existing hydro plants. Number 4, renewable energy projects like hydel, solar, biomass, wind, tidal, and others. Number 5, other suitable projects and products in various sectors of core sector engineering like power, steel, mining, oil and gas, maritime, material handling, etc., and infrastructure. Number 6, use of artificial intelligence in applicable areas including welding technology, associated manufacturing work, and operation and maintenance. Number 7, industry-focused education and training. In consideration of safety issues, classification society concepts will be introduced in hydro and other general engineering sectors in Similar to maritime industry, where third-party agencies are involved in a big way to manage and ensure strict enforcement of safety at all times. To the best of our knowledge, the above unique concept and initiative will work for the first time in India and possibly first time in the world. The center of Team IIT and Team IIT of IIT Guwahati, Guwahati Technology Innovation Hub, TIDF, and acclaimed industry experts organized by partner GBS Energy Private Limited will work for industry and infrastructure sectors for the first time in India. Effective combination and deliverance of qualification experience, theory, and practice with added engagement, utilization of highly experienced knowledge resource pool of senior citizen technocrats towards making Atmanirbhar Bharat. Thank you. Now I will go to the today's seminar. I will just declare the name of the speakers and the program details. The subject of today's seminar is safety overview in various engineering and infrastructure sectors, present status and measures to ensure total safety. The inaugural session will continue from 3 to 4 p.m. and in this session, the participation will be from Dr. Nishit Ranjan Mandal, Chair Professor IIT Technology Innovation and Development Foundation, CIH Division, former Professor and Head Department of Ocean Engineering and Naval Architecture, IIT Kharagpur. Then Professor S.K. Dwivedi, Project Director, TIDF, IIT Guwahati. Mr. N.N. Datta, CEO, TIDF, IIT Guwahati. Mr. Amitabh Ghosh, Director, GBS Energy Private Limited, ex-Senior Vice President, TechMaco, and ex-Director of Titagarh. Mr. Balraj Joshi, ex-CMD, NHPC Limited, Technical Member, NCLT, Kolkata. Mr. Niranjan Saha, Director, GBS Energy Private Limited, and ex-Director of WBPDCL. After that, there will be a main session. There are two main sessions actually, and two main sessions. The speakers are in the main session number 1, Dr. Pankaj Biswas, Professor, Department of Mechanical Engineering, IIT Guwahati. Mr. Ashokendu Samanta, Chief Surveyor and SVP, Indian Register of Shipping. Mr. Santosh Pal, Indian Register of Shipping, Head of HSC Services for ISSTL's Industrial Division. Then Mr. Sahadeva Khatua, ex-MD, Odisha Hydropower Corporation Limited and ex-GM of NHPC. Then Mr. Suresh Kumar Gupta, MD, Crane Manufacturing India Private Limited and Crane Solar. Then Dr. Rana Datta, Safety Consultant, Heavy Engineering Industry, ex-ISCO, presently in Electrosteel. And Mr. Achinta Kumar Sarkar, ex-ED, ISCO, and he is a steel expert. Then there will be a break for 15 minutes and then it will be followed by the main session 2. In the session 2, the speakers are Mr. Arunav Datta Gupta, ex-ISCO and steel expert. Mr. Amal Sengupta, expert material handling, mining and steel sectors. Mr. Pritish Kumar Sen, ex-Tata Steel and ex-head INSDAC, and presently he is head of Steel Tech. Mr. Tapan Bakshi, mining consultant, West Virginia, USA. Mr. Saroj Kant Singh, associate vice president, Power Plant Engineers Limited. After the two technical sessions, there will be an interactive and valedictory session, which will be conducted by Dr. Nishit Ranjan Mandal and Mr. Arunav Datta Gupta. The anchors for the whole program will be Mr. Arnab Banerjee, myself, Director Steel Tech, and Mr. Anirban Datta, who will take over in the second half of the webinar. Mr. Datta is the Honorary Secretary of WBSC, Institution of Engineers India. The program online coordinator is Mr. Pallab Adarsh. Over to you, Dr. Mandal. Now I hand over the session to Dr. Nishit Ranjan Mandal for starting the inauguration session. Over to Dr. Mandal.
Okay, thank you, Mr. Banerjee. Thank you very much. And once again, on behalf of my personal behalf and on behalf of the organizer GBS Energy Private Limited, I once again welcome you all to this workshop I would say, pertinent importance. As has been already talked about, that is the safety overview in various engineering. We know, but maybe those who are not involved with shipbuilding, those who are not aware of something what is called classification society, there is a concept of classification society, like Indian Register of Shipping is one such classification society. There are many world over, right? So primary business, what they do, because as you know, ship being a structure that is offshore in a very, very harsh environment. So we'll have to have a very, very stringent norms to be followed as far as safety is concerned, like in nuclear power plants, for example. So what's done here is that right from the design stage till so-called the decommissioning stage, at all stages, there is a continuous monitoring, continuous involvement of this classification society. Because safety, it's not something that it is only at the design stage, or not only at the construction stage, or not only in the operation stage. It's all through. Unless things are properly designed, the following result may not be good. Unless they are properly constructed, results may not be good. Unless the proper material are chosen, safety may be compromised, and so on and so forth. It continues. So association of a third party like classification society is very important. I mean, they do a very important job in that process. The safety is ensured. So probably some such similar concept can also be implemented while working out hydroelectric plants or other engineering sectors. So with those ideas, we have gathered here today, and I'm sure there are, as you have heard, there are various experts, really very senior experts who have spent their lifetime in various industries looking after various issues. So they'll be sharing with us, we'll be hearing them. So with that brief few words, I would like to request Professor Dwivedi. I'm not sure whether he has joined. Professor Dwivedi is the project director of TIDF, that is Technology Innovation Development Foundation of IIT Guwahati. I would like to request him to say a few words.
Professor Dwivedi, are you there?
Okay, if Professor Dwivedi is not there now, then yeah.
Next speaker is Mr. N.N. Datta.
To Mr. N.N. Datta, we can request, yes.
Mr. Datta, please continue.
Yeah, hi, good afternoon. I think, personally, I think it's a privilege for me to be in a forum like this. And I know there was, this is not the first one. We had a brief interaction post the Sikkim disaster. A couple of things which I was wondering, when we were talking about the safety aspect of it, if you look at the application per se, and especially with respect to us, that is TIH at IIT Guwahati, I was pondering with some of the data points, I think, and I'm sure that these are the areas where actually we are working. So I think I'll put a couple of data points which would be a premise on which we are planning to work on. Okay. See, if you talk about, India accounts for about, what, 2.5% of the world's surface area, roughly about 4% of the world water resources, and about 16% of world population. Precisely, if you look at the primary data point. There are about, I think what we understand and what we are working on, there are about 10,500 rivers and their tributaries longer than 1.6, 1.7 kilometer each. That means the annual flow in all the river basins in India is estimated to be about 1,870 odd cubic kilometer. This is, of course, a data point that we need to keep in mind when you talk about safety aspect of it. As per the information from Central Water Commission, CWC, when you refer to the report of 2019, India has roughly about 5,264 odd completed dams and 437 under construction large dams. We talk about large dams. We're not talking about the smaller ones. Now, these dams are generally 10 to 15 meter in height. The length of the crest of these dams are more than 500 meter and contains more than 1 million cubic meter of water. Now, similarly, if you talk about the many of the dams that we have visited a couple of dams. Many of these dams are aging and requires continuous health monitoring. And we are part of NMICPS. Come to NMICPS a second letter. We can actually, I think what was being quoted, we really can play a significant role. And I am getting much more confidence when I look at this panel of experts that we are having over here, right? And another data point, which also a very significant one, and since I have worked across the coastal areas of this thing during my telecom journey, there are roughly about 7,500 kilometers of coastline in India we have, where CPS integrated with underwater vehicles can play a major role in maritime security. Surveillance, underwater tourism is one area that we are exploring, and some other ecosystem study, archaeological heritage exploration, what we happening in Dwarka, and restoration of the safety of global economic activities taking place, which is in Indian Ocean as of now. Now, who are we actually? I think there is a kind of an idea, but just to give you a bit of understanding of it, we are a part of the National Mission for Interdisciplinary Cyber-Physical System, which we call in short NMICPS, governed by DST, Government of India. Now, this is a tripartite kind of agreement under which we work. One is Government of India, DST. Then we have got the host institute is IIT Guwahati in our case. And there is a Technology Innovation and Foundation Development Corporation. So Foundation Development Foundation, this is a Section 8 company. So this all put together comes the TIH, Technology Hub, where I happens to be, managing the operations for this company. Now, we work in the line of initiatives by the Government of India, like Sustainable Development Goals, SDGs, quality of connectivity, Digital India, Make in India, Skill India, Stand-Ups India, Smart Cities, Atma Vikashit Bharat, which is aligning to Industry 4.0 and Society 5.0 kind of situation. Now, we undertake a lot of innovative projects and will help to develop technologies of national and international importance as per the mandate. We are there to generate high quality manpower, train manpower. We help with incubation centers. We help with skill development programs, with training schools and all. And of course, another area that we are very active in terms of startups and supporting the startup ecosystem, fundamentally, which is coming in the area of CPS. Now, like we have got such 24 technology hubs across the country with all the IITs. Every IIT is governed under one particular mandate. So our mandate is technology for underwater exploration, and we focus on water bodies and various CPS-related applications. So what we were talking about it and the today's discussion, I presume we are actually going to connect with the same thing, that how to ensure safety across when you talk about our river bodies and retrofitting of all those infrastructure that is there, aging, old and all. I'm sure by the end of the session or by the end of this particular meeting, we would be having a kind of a clarity. And there I can see one or two experts who have been a party to one of our project that we are currently, overseeing and exploring, which could be a big, significant project that we would like to undertake. So we are open to it as a foundation, as a body. We are open to it for projects, for startups and technology development. So even you have any kind of inclination towards any of that subject, we'd request you to connect with Dr. Mandal, who is associated with us, and we can take it forward from there itself. Thanks for giving me this time to explain what we do and what's our mandate and what's our objective. And thank you very much for organizing this particular meeting. Wish you all the good luck, sir.
Thank you, Mr. Datta. Very informative. And now I request Mr. Amitabh Ghosh to say a few words in the inaugural session. Over to Mr. Ghosh.
Thank you, Arnav. And good afternoon again to everybody. At the outset, I would like to talk a few points on safety. Safety isn't a priority in the Indian mindset. Anytime, anywhere, for any reason. And this is a dangerous cultural deficit. I mean, that's why we need initiative, mission safety, to be enforced and ensured in all sectors for benefits of industries and society at large. Safety is a very broad-based subject encompassing all areas of work. Finally, we would like to make our life safe. Now, areas covered under safety could be design safety, manufacturing safety, quality safety, transportation logistics safety, construction safety, commissioning safety, operation and maintenance safety, and finally accident safety. Now I will come to this point, operation and maintenance safety. Very important. Recent disaster in Sikkim and what happened, I believe this is because operation and maintenance was not done properly in Tista 5 and Tista 3 due to not proper operation of gate. Now, what I believe that today's artificial intelligence technology can be suitable or used for gate operation so that even when there is human error, disaster can be avoided. Because this is a very important point where Center of Excellence can work. That is, IIT and industry can work together for a system which can be applicable for all gates pan-India. This can be a contribution of us, which is not there. Today we always talk about natural calamity, but natural calamity will not come with a prior notice, obviously. So one has to take care of that. Geological surprise, all this more. Now, next point is, so there are 3 points. Point number 1 is safety rules, regulation norms generally exist for everywhere, all engineering sectors. Point number 2, the same are not followed or skipped or bypassed many times, knowingly or unknowingly. All of us have faced similar situation in our professional life. Sometimes we try to solve, sometimes we are silent due to various reasons. So point number 3 is how to bridge the gap between 1 and 2 so that we can ensure total safety. Now, to achieve the same, as Dr. Mandal discussed, that we discussed on this point, and we have some model area, model sector, that is shipping sector. For me, there are 2 sectors, because I also had the opportunity to work in Gardenese shipbuilders, so I have some knowledge about ship industry and general engineering. So I have seen that model sector, safety sector, which can be followed is shipping industry. And also, I would say about one model project, that is 900 megawatt Purulia palm storage project under WBACDCL. I will talk about that. So first is the model sector. Model sector, If you see, shipping sector and hydro sector have some synergy. Both are based on water. I mean, benefits of this business industry is from water, but again, unsafe situation or even disaster can happen due to water only. So while shipping sector, through their modality, has taken care, unfortunately, hydro sector could not do that. And what they have done very strict third-party inspection. Unless that is done, the ship will not be insured. So insurance will happen only after they get third-party insurance clearance. So I feel similar line in customized format in hydro as well as in other general engineering sectors that can be followed. And now coming to model safety project. I have told 900 megawatt Purulia pump storage project, in my opinion, West Bengal under WBSEDCL, in my opinion, it's a model project. How? There is a success story. This project was completed before time. Started in 2002 and ended in 2007. Completed within budget, 2,500 crore against 3,000 crore. And overall plant efficiency more than rated figure. But apart from cost and time schedule, quality and safety of this project was super excellent. Zero accident. Far better than any hydro work in India, I can say. Because I have worked deeply in that. And this excellent quality and safety helped to ensure time schedule within budget without happening of accident. And this work was done by us only. We Indians have done, but under the supervision of the Japanese. That is the difference. So this is a point which project we can follow as a model. And there are other points I would say that here the stage inspection was done very minutely so that there is no major defect at the end of the work. I will tell another point that about steel. Steel is the basic material for all projects, equipment, infrastructure everywhere. And there are two sectors, primary sector and secondary sector in steel. We always try to take steel from primary sector because test certificate from secondary steel sector can be done, anybody can do anything. It's a very dangerous thing. And even from the primary sector, I have an experience for a Tista 5 NHPC project. We imported steel from a very reputed, I am not naming, from abroad. And after getting steel, thousands from steel, we found that the steel is pitted. There I thought if there was a third-party insurance, third-party inspection, it would not happen. And then they are giving all excuses and all these things, and we have to suffer. So this is another. And another point is area is construction. 38 fatal accidents happen every day in construction sector, most hazardous sector. Now, Construction Industry Development Council, CIDC, a government body instituted under Niti Udyogo, designed a 2-day training cum certification program named Kawach. CIDC issued certificate to construction workers with safety knowledge. I feel that similar endeavor can be initiated by us or the COE to educate workforce regarding safety. We know that construction sector, hardly safety is followed, safety rules are followed. So with that, I would like to finish my speech. I now request Mr. Balraj Joshi to deliver his keynote address and all. Mr. Joshi, I would say that he is a very reputed man in hydro world. He was a CMD of NHPC, and then he is now honorary technical member of NCLT, National Company Law Tribunal. Mr. Joshi was involved in the design of the hydro sector, so he has got a profound knowledge, inbuilt knowledge in the hydro sector. So I would now request Mr. Balraj Joshi to give his address. Mr. Joshi, please.
Thank you, Ghosh. And it's a real pleasure that I have been asked to speak on the safety in particular in hydropower sector, because That's a sector where I have been working. I have worked for about 37, 38 years. Uh, I had assembled a presentation. In case there's a time for that, I can put up the presentation for everybody's benefit. Of course, much of it has already been spoken. In case Mr. Ghosh says that we have time, I'll just try to put up that presentation. Do we have time, Mr. Ghosh, for the presentation, or should I simply give my ideas? You're on mute, Mr. Ghosh. You're on mute.
No, I think you can go ahead with the presentation. I mean,
Please go ahead. Please go ahead.
please go ahead. Yes.
So do you see that now?
Yeah.
Yes. Okay. So it's a very gory site. If you see, this is a site of the Morbi bridge that had collapsed, killing about 100 people. And on the right side, you see photographs of the slope failures from a few of our projects. And the lower bar on the lower frame is from Bhutan. It's from okay.
Your presentation is
Not visible.
song on off screen. Yeah.
Yeah, it started. It was okay.
It
Hey,
was
sorry.
upload again.
But again it has paused. So you can start reopen it. You can just reopen it and
Yeah,
start.
please reopen.
Okay.
ढुके कैसे?
I will do that. Is it there?
Yeah. Now it's okay.
Yes.
Okay.
Yes.
So I'll not venture to go into the full mode because probably that will be a problem.
Mm.
So anyway, this is the photograph. Can you see my pointer also, by the way?
Yeah. Yes,
Yes.
we can see.
So this is from the infamous Morbi bridge collapse where about 100 people died, and this is a photograph from one of our projects where slope failure had occurred. And this one particularly from Bhutan project, a very I should say a sorry state of affairs here because the dam is held up for last 4 years almost because of this slope stability issue, and we are not having any idea of how to handle this situation. I would not. I would try to skip some of the slides because some of the things have been spoken by already the previous speakers. Infrastructure, as we know, there are the public facilities. I'm not going to go into details of this, but there are roads, airports, ports, railways, everything that is required for making our life quality better. But why I have chosen hydro is because I've worked in hydro, and also I feel that hydro sector is one such sector which encompasses everything. All the various kind of constructions, design issues are involved into the hydro. So therefore, if we are able to take care of the safety issues in hydropower projects, probably we will be setting standards for other sectors also to follow. We can see this from this photograph, which is not very clear, but it's a dam here. River flows like this, and we have a tunnel in the mountain which delivers the water to a powerhouse and is let out again in the same river through this tunnel. Meantime, in this powerhouse, power is generated. So why I've shown this simple graphic is because you can just have an idea of how many safety issues we can have. We can have a water leakage here in this. We can have a collapse of the tunnels inside. We can have leakages from the tunnel if the covers are less. We can have problems of stress and stability in underground powerhouses. And also we can have problems like we had in Pisa, there's the trough and dams getting overtopped and water getting uncontrollably released. All said and done, in the unsafe structures, you have the public safety element, which should be given a paramount consideration. The whole idea is that we have to build in the safety aspect in our minds right from the beginning. Otherwise, you can have foundation settlings differently, slow failures, leakages, busting of pressure shafts, as Mr. Ghosh was telling about the power penstocks. Then in the process of construction, also a lot of accidents and casualties happen. And most of it happens because we are so casual in everything and we are not following the safety norms properly. Coming back to our main issue of the safety in hydropower. This is a photograph of a Tista Load M3 where Mr. Kapoor also worked. And we had a lot of issues here in the project about the slope stability. It led the project behind by about 3 years, coupled with the floods, etc. But ultimately, we were able to overpower it and come out. But probably this gives us a case study as to how the safety should be built in right from the beginning, which probably was missed by us in the beginning here in this project, and we had to put in extra time and money. The next failure, as already has been discussed, is about Tista 3 dam. You can see the gory site of the dam getting washed away like this here. Before it was a good, full-fledged, nicely performing power station. The downstream damage to Tista 5 dam is also very clear. This is the Tista 5, the beautiful, the monument of engineering, which we had called it. It got washed away, overtopped, and all the beautiful things done by Mr. Kapoor were washed off. Because the dam's gates here could not be opened in time, while there are existing protocols as to what is to be departed and done. And this is manual of the gate operation is placed in the dam control room. Still, some other considerations like we must have more power production, and particularly here the issue was the people involved here did not have an idea of the flood. What does the flood mean? What happens when a dam is impounded by a potential flood, which is almost equal to blind flood? So that's another issue which we would like to touch upon and go by. Mr. Gold said that the safety is not in our blood. It's not a culture. We don't have a safety culture. We agree with that. And when we run through this presentation, I would also like to just flag an issue that everybody involved in the design, construction, operation, and maintenance of the plants must know the golden rule that if a thing can go wrong, it will go wrong. If a thing can go wrong, it will certainly go wrong. So with this idea in mind, we must have a look at the formulation stage, what the role of S&I, the survey and investigation. While designing, enhanced safety has to be interwoven, use of improved tools, safety of the structure during construction, safety of personnel and equipment during construction. Why I'm outlining all this is because when a person is formulating a project and when as it steps on to the various stages, passes on from the formulation to design to construction, everybody involved must have an idea as to what he's writing in the specification and what is the safety fallout of that particular word. So this needs to be inculcated in us, and how it is to be done, we will come to know shortly. Before that, I have just tried to quickly pile up all these together. What are the safety ingredients? Which are the elements which we have to look at? So I will not read that entire list, but as we go by, we will come to get a hang of the thing what I wanted to say. So this is the life cycle of the project, right from formulation to design to material selection to workmanship and risk management. And another element here now is the climate change perspective. A few years ago, you know that the Government of India had issued a circular before this Ministry of MOEFC and CC came that climate change is not there. So please do not refer anything to climate change at all. But it was only after the international conferences started happening and the COP21, 22, etc. happened that then we have a Ministry of Climate Change. Now the Government of India has also realized that the climate is changing. For one, I am not a very great subscriber of the word climate change because we have very limited data set with us. But in any case, it can't be denied that we are experiencing very intense rains in very short periods of time. So probably we can call it at least a weather change, if not the climate change per se. But anyway, it's there, and GLOF has happened. The global temperatures are rising, and then the glaciers are receding. These are the facts which everybody knows. And all our planning for the hydro projects, unfortunately, is based upon a paradigm when this was not there. So now that brings a big question mark on our planning paradigm and process. Shall we continue to plan our projects in a way we have been doing earlier, or should we revise our methodologies? And role of government in this has to be outlined. So we will see that in this presentation. So object of the infrastructure, what is the life cycle, what is the life, is a temporary structure, permanent structure, or estimated life. Because ultimately at the end of the day, the resources are scarce. We are not having so much of money that we can really go, very spend a lot of money on everything. So that's one thing which probably gives us also a reason of playing with the safety. So therefore, if we go stepwise and we find, yes, here is the structure which is going to be a permanent structure, and I must not cut corners here. I must provide for stability. So that's where objective of the infrastructure is very required to necessity to be drawn in beforehand. Then formulation and planning, public safety has to be kept in view. As I said, if it can go wrong, it will. We had a tunnel in one of the Uttarakhand projects, which was very nicely built by a foreign contractor, but there was a possibility that there was a shear zone cutting across the tunnel, and it could actually give rise to a uncontrolled release of water. But people said, no, we have given enough grouting, enough supports have been given. But finally, ultimately, the inevitable happened, and there was a village which was which got affected, which almost got washed away, and therefore our general manager of the project was also apprehended by the police, etc. So many complications happened. So if we know that something can go wrong, this will go wrong, and the additional protection has to be given, must not be lost sight of. Of course, we have detailed, IAS codes for estimation of forces and everything, but still, Kopuli like things happen. In Kopuli penstock, it got burst. Then what happens to the foundation if we have expensive clays? What happens, like in Uttarakhand Sulani aqueduct, there were some uncertainties were there, but the British designs had provided for those uncertainties. That's why it could sustain. Similarly, we come to investigation and material properties, the the interface of the geology and geomorphology with the infrastructure projects is very paramount. But we also know that whatever number of investigations we might carry out, there is an inherent limitation in investigations. And therefore, a judicious approach has to be adopted as to really, are we going by the reading of the given meter, or are we really having a judicious approach towards the thing? For example, the Bow Bazaar metro, if you see, what happened? The subsidies took place in a great deal around that chamber where the metro was getting built, through which metro was getting built. But people had probably forgotten about the geomorphological aspect here. I'm not going into that aspect in detail, but to my mind, I visited that site after the collapse, and I find that River Hooghly was somewhere flowing here, but probably that was not very correctly mapped and taken care of. That is what I mean to say when we say we have inherent limitation of investigations. So we must understand, we must read, study the surface condition, morphology, etc. ourselves. And that is why at the formulation stage, people of very high caliber and experience are required. Then optimum design, etc. So here I want to give a small idea that we have to have a design engineers who are licensed, like they do in USA and elsewhere. Now today what's happening is everybody, once you call him a design engineer, he's supposed to know everything about everything, which is not a very correct philosophy. The technical specifications also should be updated. We know for sure that because of following of the old specifications, some collapses have occurred, some projects have languished, therefore we must change that in good time. And they should be followed scrupulously. How we follow scrupulously, will come to it. As I already said in relation to the survey investigations, you have to provide for a variation of the material judiciously in the design, that this property, the value which I'm taking, probably it can be safely downgraded to these levels. Now here, this comes by experience and also by the exposure, that how much of factor safety I can really go for, even though the code provides something. But if I have a hunch that, no, I think the code provides way too higher effect of safety, I should probably increase the effect of safety a bit more. That has to be thought about at the formulation stage itself. About the construction techniques, and whenever we talk about safety, the first thing which comes to our mind is the accidents. What happens? People die, people get crushed under the dumpers, which doesn't have a reverse signaling. People get, I have seen people getting drawn into the conveyor belts and getting killed, and also getting into the batching plants and getting killed. So there, the safety has to be really a watchword, not only as a theoretical word, but think that this wrong can happen. And therefore, people who are in charge of the work sites not only should look after the progress and the specification, but also about the safety. Of course, we have to have the safety experts on all the projects we do have. But these safety experts are not given the kind of respect and the kind of wherewithal which is required by them. And whenever they try to stop a work, they're called upon, and it's said that they have some other ulterior motives. Now, I just wanted to talk about Moby Bridge. Why here? Because it was told that it was designed only for 400 people, and probably more than that. They climbed on that, and that's why the bridge collapsed. What I tell the designers here is that if 400 people can climb the bridge, you please design your bridge for 450 people. Even though you put a board for 200, you should be reasonably sure that people after 200 will not stop, because your bridge can accommodate people of 400 odd figures. And that's what happened here. They had put up a board, not more than 100 people are allowed, but 400 people went there. So a thing which can go wrong will go wrong, as happened here. So therefore, licensing of the fertilizing professionals for 5 years, then automatic process controls, use of precast concretes, etc. This is being done by far, but not on all the infrastructure projects, at least not in hydro projects where we still have the concrete mixers and the head loads, etc. going on. And this particular point, why I put in red, is the poor supervision is a safety hazard. So this is what happens. This is what happened in Penstock Burst incoming project, where supervision, which was required at that particular stage, every stage of the construction, was not there. Why? Because there were no supervisory staff available of that particular caliber and training. We expect a simple work assistant to go and supervise the welding of the penstocks also, and also he will also be required to supervise the concrete placement, which is a very recipe for disaster. Then jugaad, I said, is the biggest enemy of the safety and sustainability. Whenever some people say that we do a jugaad, don't agree with them. Let's say that it has to be done the right way. Then finally, the risk management. As I said, in Pista 3, it was known that there was a looming glacier lying over our heads, and still we have gone for a fill dam there. Probably a proper risk analysis was not done. I will not say more on this because downstream we have another project which also got damaged because of that. And risk management and risk sharing with the contractors, that is a thing which probably we are not at all exposed to. And thereby, whenever a tragedy occurs, we say, okay, we had not considered that, this was too much. The courts say only a PMF has to be considered. They don't say that what happens when the glove is to be added to this. So very many excuses are put up. Climate change perspective I already spoken about in my talk over other slides. But here you can see another safety hazard which is there in the hydro projects, with the accumulation of silt behind the dams. With the passage of time, this gets filled up, and a new zero elevation of the river is achieved, whereby the upstream areas start getting too much floods, even though it might be 1 in 25 years flood. But since the river bed has risen, so those villages also get inundated. This aspect should be built in the design itself. Then we come to cost estimates and financing. The picture which you are seeing is one from a roadside in Japan. We were traveling from Miyazaki to some other place, and we stopped by at these locations. We find that an elaborate system grid of the concrete beams and rows and columns, etc., has been put, which is duly anchored by the long cable anchors. I don't think for a slope of about 30-35 meter high, we will in India, we will take any such precaution. We simply go by the old methodology of construction of hill roads. And I would not say that Gref was responsible for it, because that was the time when India had just become independent. They have only two categories. One is rock and another is SMB, soil mixed with boulders. So if they find it's a rock, they will blast it away. If it's SMB, they will put a dozer at the bottom and let the hill fall, and uncontrollably so, as you have seen in Himachal roads also. Recently, when this calamity occurred there, all the roads collapsed. The main city of Shimla was cut off for about 7-8 days. Why? Because systematic cutting was not there. No supporting was there. And why it was not done? Oh, we don't have that in our estimate. How can we do that? I say, do not cut corners. Even if we are a developing country, but playing with the public safety is no excuse. That should not be done. The authorities who are responsible for sanctioning your project should be told that these things are required for public safety. Then finally, we have the monitoring and maintenance. We continue to monitor the projects which we have constructed. Earlier times, only dams used to be monitored. And here I would like to tell you a small anecdote about this Lanux Dam, which is in France, which we visited in 2013. And it was constructed somewhere in 1980s or so. And the important part of this dam was there's no road to this dam. It was done by by the cableways only. But when we went to the dam gallery, we were surprised to see all the instruments were beautifully working even then, and a proper log was being maintained. I am sorry I cannot say that for the Indian dams, because I've been into the dam construction and operation and maintenance, everything. But most of our dam instruments, they are not non-functional. This is one of the major issues for dam safety. The dam safety bill has come in 21. It says so many things, theoretical things, but we know for sure that these are not there. And we don't have really an idea how to go about that now. How a dam is now going to behave. We are complacent that this dam is staying there for 30, 35 years. No, it can't go anywhere. And the case of Mullah Periyar Dam in the southern states is a case in point here. People said it can get washed away, but ultimately studies were done say no, this is safe. And that took about 1 year's litigation and strenuous efforts by the engineers. But if a structure can tell about its own safety by monitoring instruments, why we do not go for it in a big way? So I say use the instrumentation liberally. So at design stage, we have various codes which are more generally followed. So factor of safety are to be inbuilt there. This is already being done. But what takes the cake sometimes is that many times things like AAR happens, and designers would like to put the entire blame on the construction engineers. So I would say that as far as the design standards are concerned in India, they are more or less all right. If they are followed scrupulously, they should be that should serve us well. And wherever such design codes are not available, we are free to use a European or US codes also. That also by giving a reference you can use. So for design safety, I am not saying as the structural design safety that the standards are not there. They are very much there. The use of geotechnical interface tools like SAP, etc., FLAG 3D, etc., is certainly should be welcome. We have been using them, and they have been found to be of much use to us. That gives you better understanding of the soil structure in interaction, and where in the structure stresses are going to get piled up, and there you can provide your more of your support systems. And geologists and engineers must work together, must have a synergy. And I am certainly for it. We must use these tools and should not, with a wave of hand, say that no, these are all theoretical things. It's not like that. Now we come to the safety specification construction contracts. This is I have taken from a real contract, where in the safety chapter we say that a contractor would give a safety program and its implementation, safety standards. Huge essays are written on everything. These are possibly all the ingredients which you can think of in a safety ecosystem, which says safety, rescue team, illumination, earthing, control of electric discharges, and the list goes on. Blasting, underwater blasting, how it is to be done, what precautions have to be taken. But there are challenges in implementation of the specification. Why? Because they're only suggestive. People are apprehensive that if we write so much in detail that he must be doing this, unless he does this, his payment shall not be released. That is going to make our project costlier. So just for the namesake of to fulfill a formality, we are writing specifications, but we are not following them in the good stead during construction seriously. This is another slide which I have prepared from another project of NHPC only. This is regarding fixed wheel gates, where a QAP, the quality assurance plan, was given. And everything is nicely, very neatly and meticulously listed. What are the requirements? Material verification, test, examination, ultrasound, operating test, thickness, spark testing, mega water, you name it. Everything is there. And then the performer also tells you which are the witness points, which are the keys, and then finally the OK card. That OK embedded part material verification inspection code is so and so, and then finally we get it signed also. We have given standards also, which standards are to be followed, whether given in specifications or IES or whatever. So the wherewithal is already there, but it shouldn't be used as a formality. This has to be tied up with some payment considerations, the payment conditions. That's why. And the last but not the least is the exchanging of the best practices. Now in Teton Dam failed in US in 1974. A very detailed inquiry was held, and we were fortunate to have that particular report in our library in NHPC, which I had undergone way back in 2002 or 3. And surprisingly, there was nobody who was faulted, nobody was punished. It happened. Why it happened was very neatly and very elaborately talked about in the report. But we know that nobody was hanged for the Teton Dam failure, which actually killed a number of people. A whole dam failed within a matter of 16, 17 hours. Similarly, the Vine Dam in Italy and Malpasset Dam in France, such failures were never encountered again because they learned lessons from it. So therefore, we need to ascertain the cause of the failure of the problem, not to dump the blame. And the onus for doing that lies on us all. Whosoever are involved in any capacity, they are responsible, because at the given time, they probably might not have transmitted the knowledge which they had, so that another disaster of a similar nature could be avoided. Then the role of government. All this is, we say, good to hear. We know that our physics is very good. We know how engineering works and everything. But finally, we have the cases like Morbi happening every now and then. So government must improve the safety standards, and third-party inspection, etc., has been made. Already points have been made, but this is really a major issue. We are quite wary of a third-party inspection. Particularly the client organizations who are designing themselves, they are very wary of a third-party inspection. They say, no, we know. We are know-it-all people. We know everything. We don't need anybody else. But for the safety part of it, it's essential that a third-party inspection is made mandatory. Not only that during construction, during design as well. Then I've spoken about the effect of climate change. And then one aspect here I want to underscore here is the define no-go areas. We are all talking that this shouldn't happen in Uttarakhand, this shouldn't happen here and there. Why doesn't the government come up and say that we are not going to allow any of the hydro projects above a particular level, or define those no-go areas very meticulously? This has been done afterwards in Tapovan in the Uttarakhand area, but I think this needs to be done for all the river basins where we find that there are issues involved for which we have no definitive solution, and they can be a safety hazard or public safety hazard. The government must come clean with the policy of no-go areas. Well, finally, the conclusions. A safety culture needs to be developed across the country. Third-party reviews will be made mandatory on all the processes. In all the process of design, construction, wherever possible, a third-party review must be made mandatory. Specialization requirements through appropriate legislation. For example, licensing of design engineers for 5 years, and then you can again renew that. Train the field supervisors and deploy them trade-wise. Don't ask a person who is in charge of the welding job to supervise concrete placement. Contracts to have QAP formats for all processes, right from the formation, design, construction. I find even in NHPC also, even though we were an ISO organization, but in our contracts, we did not have those formats, which should be made mandatory. Otherwise, the quality cannot be interwoven into the entire process. Then learn from our mistakes. Encourage the industry, academia interaction and reviews for improved design and construction practices. Now, all these requirements are very well known, but who is the authority who is going to do it? So here's my last idea, and I leave you with this particular thought. Should we have a Ministry of Construction, which can really look after all these aspects and be a central figure and coordinate everything, so that we don't have failures like this moving? Thank you so much.
Thank you, Mr. Joshi, for very useful information providing us. And now I would request Mr. Niranjan Shah to take over for the final speech of the inaugural session. Over to you, Mr. Shah.
Good afternoon, Dr. Mondal. Mr. Datta, Mr. Joshi, and my friend, Mr. Amitabh Ghosh, other speakers and participants. Earlier speakers have already addressed about the importance of safety aspects to be followed in various engineering and infrastructure sectors. Particularly, Mr. Joshi in his lecture has given very vivid and touched all the areas about the safety aspects to be followed during construction, particularly equipment manufacturing stage, commissioning, and also during operation and maintenance. I was associated with thermal power projects for more than 45 years. And I will want to share my certain experience about the safety aspects followed in thermal power sectors during engineering, construction, operation and maintenance from earlier 70s till mid 2015. Actually, what I noted that safety aspect is very much required for both human and equipment. Earlier days, safety aspects for human was very much neglected. The owner and the contractors were not look after those safety aspects. And I have seen that contractor workers were not provided with safety shoes, safety belts, and other accessories during construction period. And due to this, during the construction time of a power plant, 15 to 20 casualties was very normal. Construction equipment was not tested properly, like cranes, winches, chain pulley blocks, electrical equipments. These were not tested regularly. And as a result, a lot of accidents occurred very frequently. But since mid-80s, the situation started changing. The owner and contractors and also the technicians and laborers realized about using proper safety accessories at construction work site. A strict vigilance from owner side and also from contractor side was a must. For this reason, the casualties was almost became nil in some of our projects at site during construction period. Now I want to tell something about the supply of power plant equipment. Generally, equipment safety is covered through various interlock and protection. Earlier days, the analog control system was used for boiler, turbine, and the total system control. During that time, I experienced that many a times, due to some fault, due to some absence of signal from the field equipment, this is not without the actual, there was no fault, but there was some inadvertently, some false signal the equipment got tripped, and even the turbine also sometimes, due to that, got tripped. So there was a tendency to the operators and engineers during that time to bypass some protection system so that this spurious tripping does not happen. But from the 80s, when DCS was introduced for control system, lot of improvement took place, and 2 out of 3 signal philosophy was introduced. And as a result, occurrence of spurious tripping of equipment was also nil. Another aspect I want to mention in power plant, that for emergency power, DG set, battery system are provided, but regular checkup of this equipment are missing. Otherwise, what I noticed that during emergency, the help of this equipment was not available. Regular drilling also necessary to check up interlock and protection by simulation. But this is not done regularly, and due to this, lot of accident occurs. Moreover, very important area like fire protection system in the power plant, particularly in thermal power plant, because there is a chance of fire occurrence many a times. The hydrant system and spray system is provided, but regular checking of the system is not done. And due to this, when actual fire occurs, sometimes we noticed that fire water pump is not running. And due to this, a very serious hazard and lot of money or equipment damage is done. Lastly, I want to share with you about one major incident happened in one of the power plant. I don't want to mention the name. And this was due to the negligence of the engineers and technicians. In turbine protection system, there is AC lube oil pump and also DC lube oil pump. Normally, the AC lube oil pumps are running, and another standby AC lube oil pumps also there. And in case of absence of any AC power, standby DC pump starts and the lubrication system is maintained. But I have seen that there is a provision of checking to simulate that whether the system is okay or not, whether DC pump is starting properly due to low pressure in the oil system. And in the manual, it is also given that weekly checking is necessary. But in practice, I have seen that this was not done properly. And due to this, many times, a major accident occurs. And in that power plant, a major accident in the turbine took place. and it was due to maintenance of DC lube oil pump, local electrical panel maintenance was doing by the technicians, and during lunch time for half an hour or 1 hour, they kept it as it is and went for taking lunch. But what happened during that period, due to some external fault, the transmission line, the unit tripped and total power failure took place. There was no AC power in the plant, and the DC lube oil pump also not there available, as the panel was under maintenance, and due to lack of this lube oil system, there was no oil in the bearing, and all the bearings of the turbine got damaged, and the turbine shaft, due to this, the turbine shaft also got bent. The unit was out of service for 7 to 8 months. All the rotors had to be sent to the manufacturer's shop. This was a major accident, but this is sheer negligence of the operators and the technicians, not operators, particularly the maintenance people. So to avoid this type of accident, particularly in O&M time, regular checking and drilling is necessary. So this is that aspect I have noticed. And also, I had the opportunity to take training in late 80s in UK for commissioning of turbine boiler, etc. During that time, I noticed that during commissioning of any pump or any motor or any equipment, first thing was followed, they were followed, that whether the area is totally cleaned, whether the firefighting system is available, whether all the protection is available, and then only they start commissioning. But I have seen in our country that due to any political pressure or anything, some minister is coming, so boiler is to be lighted up. So a lot of interlock system was not there, and the boiler light up was tried, and there was also many accidents occurred due to this. This is not in, even in NTPC projects I have heard this, but I am not sure that this has happened in NTPC project also. But in our thermal plant where the Japanese were associated, particularly in Bokreshwar, and also some Chinese were associated in our Shagordigi project, but they were very much meticulous about completion of all the protection system before commissioning. Otherwise, they even don't don't hear anything about commissioning of any equipment, or if there is any pressure from our side also. This is very, what I think that this is very good system, and we must follow this to avoid any untoward accidents. and damages to the equipment. So these few words I want to tell, and I hope the other speakers are waiting. So I conclude my lecture in this now. Thank you.
Thank you, Mr. Shaha. Since we are running late, I am straight away going to technical session 1, where our first speaker will be Mr. Dr. Pankaj Viswas, Professor, Department of Mechanical Engineering from IIT Guwahati. Dr. Viswas, please start your speech. Dr. Viswas? Yeah.
Yes, sir. Yes, sir. Thank you. Sir, I am just starting my talk.
Yeah. Please.
Sir, I am sharing my PPT. Is it visible, sir?
Yes, go ahead.
Okay.
Yes, it is visible.
Okay. Okay. Actually, thank you very much for giving me this opportunity to deliver a short talk on safety recommendation in welding. So all of we are very well familiar about welding technology. So today I'll just briefly introduce about what are the safety required in welding. We know that during welding process, generally there's generally developed a very high intense heat, which is developed due to inflammable gases. Once we do what is called gas welding, like acetylene or hydrogen types of gas welding, as well as in electrical welding also. So to protect the person from this high intense heat as well as high temperature droplet, generally some sort of norm is required. That means that sort of norm generally is recommended by different published authority, like one of the most important authority like Indian Standard Institution, ISI. Apart from these things, many other international organization also generally published lot of norms related to safety issue related to welding and cutting. So once we'll keep this recommendation or safety issue in mind, then we can reduce the risk a lot. In my presentation, I will brief about the following point, like how we can protect the welder. For protection welder, what are the safety recommendation is required. So then for installation of, you can say, a gas welding or cutting equipment, what are the safety recommendation is required. That related things I will briefly introduce. I will also briefly introduce in case of arc welding installation and cutting equipment installation. For that, what are the safety recommendation is required. Briefly, I will discuss all about these things. Apart from this thing, I'll just brief about explosion, fire, and other hazard, ventilation, and health protection related safety issue. So you see, generally the hazard which we got due to, from welding related activities are due to, you can see here, I have shown you, just 1 minute, I'm just highlighting these things, then it will be better. Just you see, 1 minute, where is the things? Screen. You can see this the hazard issue is due to you can see that gases or fumes, heat and burns, the radiation, then electric hazard, fire and explosion. Then you see some means welding machinery are there. From machinery related also some hazard can happen. Then trips and falls. Then confined spaces, noise and compressed gas. So these related things just briefly I will introduce in subsequent slide. First of all, I will discuss about how we can protect or what are the safety rule required for worker need to protect from these welding safety related issues. Okay, like worker need to be protected from fumes and gases. Then you see worker need to be protected from welding generated ultraviolet ray. Then orca need to be protected from flying sparks or metal globules, hot slag particles, and falling when welding at height from the ground also. So I will just brief about fumes and gases. Generally, for protecting welders from fumes and gases, these are the following points you need to know. That means, first of all, for from fume and gases, always we should keep your that means welder heads from the fumes. How it is to be done, that also I will discuss little bit by showing a what it's called pictures. What are the different generally accessories required to protect from fumes and gases? Then from arcs ray, during arc welding process, they are develop very high intense ultraviolet ray and infrared ray. To protect from this ultraviolet ray and infrared ray, generally there is required to use some what it's called shield glass, or you can say some helmet also is there. What are the helmet and what are the glass type generally we use to protect from arc ray? That also I'll show in subsequent slide. Okay, apart from electric shock also, what it's called welder need to know from where generally this electric shock can come. So that related things also briefly I'll discuss. Like you see, that always you should keep it in mind. Never to touch electrode and metal, what it's called electrode and workpiece at a time with a bare hand, or you can say skin with or skin or wet clothing. So that's why what happens whenever we'll do the welding operation, these are the different points we should keep it in mind. These are the safety related issue. Apart from these things, for welding safety also, we should protect the welder from sparks and spatter also. For that, there are different types of what it's called gloves. Then some apron also are there. What are those apron or gloves? That I'll show you in subsequent slide little bits, because my time duration is very less. That's why I'm going little bit faster way. Okay, like we need to wear some gloves. There are some standard gloves are there. There are some leather or apron, asbestos apron are there. For overhead welding also, there are some leather skull cap or peaked cap are there. That what are the standard, that related thing briefly I will introduce, and what are the general different classification society or different standard are there, that also I'll show you. Then some leather jackets also are there. That leather jacket generally is required to protect our body. Then if cutting or deep gouging operation is required, then what happens for cutting or deep gouging purpose, generally we use some leather spat also. You see, because cutting or gouging purpose here generally spattering amount is comparatively higher. So here generally some extra precaution are required. Okay. Apart from there also we use some safety boot. How it's look like, I'll show you in subsequent slide. Like here you can see what are the for doing welding, what are the different types of generally safety clothes, safety helmets, safety what it's called goggles, and all the things required. That related things I have shown you, because without wearing all these things, if you will do the welding, then there is a risk of health hazard. That's why these are the things, or these are the different types of parts we need to know. Like during welding operation also, here what types of shade of glass we should use. Here I have shown you that for general what we used to see in workshop practice or in any industry, generally welder use arbitrary what it's called number of glass shade to protect the eye. But always you should keep it in mind, this glass have some standard. Like for SMAW welding, depending upon this current range, depending upon the electrode diameter, there are some special types of shade of glass is there that you can see. Like here the current, this shade is shed number also increase, that you can observe from this table. Apart from for GMAW welding, flux core arc welding process also, depending upon this current range, if you increase the current range, the shade of glass also is increased. Always you should keep it in mind, if you will not wear these types of glass, appropriate glass, then there is a chance of safety related issue. Apart from these things, here also I have shown you, if we increase the thickness of the plate, this thickness of the plate also have an effect on what it's called glass type, whatever the eye protection purpose glass we use. Higher the thickness, higher the shade of glass also is required. So there are some standard, that is ANSI or AWS standard F2.2 is there. We should follow those things. Okay. So here generally for protection of the work area, the prime focus should be on the following points, like hazards notification should be well published before doing the experiments. Okay, so there are some points here I have written. So you can go through these things. I will provide you this slide because I will show you little bit safety issue related to underwater welding also. Then there are some standard machinery safeguard also there. Like always, our welding machinery should be protected from human contact. Then what are the precaution is required, that safety related things is written here. Then there are some special types of protecting booth is there. Generally to do the welding, there are some, there we should use some standard protecting booth, because what happens during welding process, there is develop very high intense heat, as well as there is developed a UV ray and ultraviolet, what it's called infrared ray, which is very much harmful. Okay, that's why what happens, this protecting booth should be such, it should not affect the surrounding human beings. Okay, otherwise what happens, that's why apart from these things, in this booth, this should be what it's called properly exhausted system should be there. Apart from this thing, there should be well circulation of the air in floor level as well as in screen level also. Apart from these things, you can say there is a problem due to this UV ray, that is called what is called and wall reflectivity types of wall we should use. For that, you can see nowadays we are using some welding curtain. Welding curtain generally, you can see here I have shown a figure. Here you can observe how the welding curtain is looks like. This welding curtain have a very low reflectivity of ultraviolet ray. That's why what happens, once you do the welding inside these types of welding curtain, then chances of these types of safety related issue will be reduced. Okay. And for public exhibition and demonstration of the what it's called welding equipment, there are also required some welding safety related rules that is also mentioned here. So apart from these things, I am going to discuss little bit about safety for underwater welding. So for safety of underwater welding, because underwater welding is a very challenging types of welding techniques, which is used for mainly for repairing, and some sort of times it is also used for what is called manufacturing purpose also. So lot of challenges or hazards generally we can observe in underwater welding. So some of the hazard I am just first showing, like electric shock, explosion, hearing problem. I am not going in details for how it is coming. Everything is written here. Then there is a problem of drying. Then there is a problem of decompression illness. And there can be problem due to underwater welding, long-term health problem, then hypothermia, and some other problem also, distraction. So these types of different safety related things or different hazard generally we can observe once we go for doing underwater welding. So how it is coming and how we can protect from these things, for that there is some special safety rules are there. So here some safety rules here I am also showing. Always we should keep it in mind once we go for doing underwater welding. A welder who is doing underwater welding, always he should have a contact with his teammate. So some here also you should keep it in mind, more appropriately he must contact his colleague from time to time during entire welding process. he should wear the required clothes, because for underwater safely welding purpose there are some standard equipment, standard clothes are there. Okay, that clothes should be water resistance as well as what is called fire resistance, and he must have another welder with him for assistant during the entire welding process. And one must take proper education of the underwater welding before involving do these types of underwater welding. There are different types of what it's called safety standard are there for doing underwater welding. Some of the safety standard here I am showing. Like you see, there are some standard that is called what is called Occupational Safety and Health Administration, OSHI standard. So for doing underwater welding, we should have knowledge on these different types of standard. Like for commercial diving purpose, we should have knowledge on OSHI standard knowledge. For scuba diving purpose, we should have this standard knowledge, you can see. And for doing welding and what it's called maintenance or repairing purpose welding, generally we should have some other standard knowledge. That thing generally you can get from this following underwater safety standard norms. Okay, so this all about my talk. Actually, because my talk duration is very less, that's why I brief it very shortly. Thank you so much. Hello, sir.
Hello. Yeah.
Sir.
Sorry. Thank you, Dr. Viswas.
Sir.
Yeah. In a very brief time, you have given a tremendously good lecture on welding.
Thank you.
Sir. And now our next speaker is Dr. Ashokendu Samanta, Chief Surveyor and SVP Indian Register of Shipping.
Yeah, good afternoon.
Dr. Samanta, please take over.
Yes. Yeah. Good afternoon. I'm audible?
Yeah, you are fully audible.
Yeah, good afternoon to everyone, and it is my privilege to say a few words on this particular seminar, which is mainly on the safety in the industry. So when we are talking about the safety in the industry, and particularly I understand this is for this hydral power point of view. So this safety is not only important in one kind of industry, in fact, this will be valid for all kind of industry. Though I am not from this hydral power point of view, I am basically from the classification society, those who are involved mainly from the maritime sector and the shipping field. I wish to share certain knowledge or experience from what are the things classification societies they are looking into, particularly when they are thinking about the safety and in the maritime field. Now, what is that classification society? Classification society, they are nothing but a third party agency, those who are actually looking into that how to maintain or how to do certain things or certain activity based on certain rules and regulations, so that certain aspects needs to be looked into. What is that certain aspect? Whether in this case we can always say that thing, whether safety or risk or reliability needs to be looked into in that particular aspect or not. Let me give you an example that when we are talking about this classification society and how actually we are dealing the safety of the ships. Now you understand that thing, that shipping is maybe one of the most regulated industry, not only in India, but also internationally. And why it is internationally? Because most of the ships, particularly international vessels, those who are plying from one port to another, they are going from one country to another country. If something goes wrong, so it will be not only affecting to your home country, it will be affecting to other international country. So that's why actually this industry is very much regulated, and it is not only one particular actually organizations they are looking into from this safety aspect. There are many international organizations, they are also monitoring the safety aspects from this particular field. So when we are actually a ship is being built, or when it is being commissioned, or when it is being decommissioned, how these aspects are actually looked into from the safety point of view, I just wish to give certain example. So this particular example may be valid or may be implemented in other industries, particularly in hydropower industries also. So when a particular ship is vessel is being built, there will be one kind of owner will be there. So that owner has certain wishes that my vessel, whether it is a tanker or bulk carrier or whether it is some navy vessels, they have certain aspects needs to be looked into when it will be built. Whether it is from the your cargo carrying capacity, whether it is from the speed point of view, or any other from the pollutions point of view, or from the particularly today's nowadays all these different research vessels are being built, or in the naval vessels are being built, whether much more some kind of a requirement is there from the from the defense point of view, from the your signature point of view, whether it is some kind of a sound, whether it is some kind of a your reflections or all these things. So when the ship is being built, owner needs as a requirement. So when the owner has the requirement, a designer they fix, they will be designing the ships. Now the role of the classification society starts from the end to end. It is starting from the very beginning. It is not like that classification society just come in the middle of this picture. No. So when the designing stages, in fact, when the information gathering stage point of view, the design stage is also being carried out, classification societies are involved. How they are involved? Because we will be telling that based on the requirements, which rules needs to be applied and what are the guidelines needs to be put into place. So based on that rules and guidelines, designer has to build that design, and then it will go to the next stage for the building or the construction of the ship. When it will be being constructed, our surveyors is also involved, not only from the beginning, it will be in every stages of the shipbuilding, because it has to be checked and it has to be verified, and then only the certification needs to be issued. Then once the ship is being built, it will be commissioned. When it will be commissioned, before commissioning, it will be every aspect needs to be checked. That is called the trial run. And this trial run also our surveyor will be in the part of this the process in addition to this owner and the designer, and it has to be checked whether all this safety and all these design aspects needs to be taken care or not. So then once now the ship is built and it is now flying, the classification society's job in fact starts from there, because each and every day monitoring needs to be done. This monitoring is very important because it is not only built. The things is once it is built, that how actually the maintenance needs to be taken care, because once the ship is being built, it has its design life might be 25 years. In India, there are many vessels is flying which is more than 25 years, in fact 40 years in ONGC vessels, many other vessels might be there. So when a vessel which is running for more than 25 years, it has to be maintained. So maintain means from different aspects, from your corrosion point of view, paint point of view, structural point of view, machinery point of view, your electrical point of view. It is in fact nowadays it is from pollution point of view. So every time that ship has to go through certain survey, and then it has to some certificate needs to be reissued. If the certificate is not reissued, that ship or vessel cannot run. So now the question, once you understand that thing, so it is not only the building, once it is built, when it will be running, so that time also, every time there are many type of certificates are there. We have some kind of a periodical survey, we have some kind of a docking survey, we have some kind of a special survey. So there are many type of surveys are there where our surveyors will onboard the vessel. They will check the things, how it is running, whether it is properly maintaining that your rules and regulations or not. If something is needed to be done, then they have to give that some kind of a advice, and then only the certificate needs to be reissued. So this process goes on this entire life cycle of the vessels. And then once the vessel is actually, the life is over, ship owner wanted to decommission that thing, that time also the classification societies are involved, how it will be decommissioning, whether it will be some pollution's point of view, whether it is okay or not. So this entire process, which we call this life cycle, it is actually maintained for millions of vessels which is running internationally. Now, Indian Register of Shipping, this is the National Classification Society of India. Similar 14 classification societies are there all over the world. Any vessels or anything it is floating on the water, it is the ambit of the classification society, that it is the requirement that owner has to take the certificate from one of this classification society all over world, and that certificate needs to be maintained throughout the life cycle of the vessels. Now the similar procedure, whether if we can introduce into this any industry, particularly in this hydropower sector, then definitely this will be more regulated. It will be not only from the safety point of view, mainly from this your maintenance point of view. So here, when we are thinking about this type of regulation needs to be done, there are two type of agencies which will be very much required to do these things. One is that thing, government nodal point, because you can understand this in the shipping field, it is regulated because it is the international requirement is there. We have the Director General of Shipping, we have the classification societies who are monitoring. It is the IX, International Association of Classification Society. We have IMO, International Maritime Organization. Those who are all monitoring to this all vessels. So it is the primary requirement of this classification society to give the certificate, considering all these rules and regulations and checking all these regulations. They can only this give the certificate, and once this we give the certificate, it is again monitored from this international level. How is the performance of this classification society? It is not only one classification society, it is the 14 classification society. You must have heard this name of this American Bureau of Shipping, which is the classification society from USA. You must have heard this Lloyd Registers, who are the classification society from UK. Similarly, there are NKK from this Japan, then Bureau Veritas from France, then DNV from this Norway. So similarly, 14 classification societies are there all over the world who are responsible to give the certificate to any vessels which is plying internationally. Now, the question is that things, when I am talking about this, I think in the last presentation, Mr. Balraj Joshi, he was talking about this government's roles and the third party certifications roles. Yes, I do agree from this point of view. If we wanted to bring such type of systems in this hydropower also, there are two agencies are very important. One is that things government, because they will be ultimately giving that yes, something needs to be followed, the rules and regulation needs to be followed. And then another society, which is the third party agency, this is their requirement actually based on these rules and guidelines, they have to give the certificate, because it is not a kind of a whims and requirement that thing I can give certificate to A or B. No, it is so when the third party agency, they give the certificate, there are certain laid down procedures are there are certain guidelines are there are certain rules are there. Indian Register of Shipping, they are responsible to develop rules for the ship. for the shipping. We have a separate rule division is there for the last 50 years. In fact, this is the 50 years we have entered. We are just 50 years we will be celebrating in this year, and we have a rule division are there, those who are responsible to develop rule for the ships. And when we are giving the certificate, we are checking from the rules and based on the rules and guidelines only we are giving the certificate. Again, our work is monitored by this international level from this, because if a vessels get detained in any international water, it is the problem of this owner, it is the problem of the classification society, because we have given the certificate and we are responsible for that thing. So somebody has to be responsible. Unless and until this responsibility is not there, nothing will work. So this problem can also be sorted out, can also be monitored from these other sectors of the industry, provided there are rules and regulations and also certain agency who will be monitoring that rules and regulations. Now you can understand that thing from the shipping point of view also. For the last 100 years, this actually shipping is being run by this your heavy fuel, where actually your oil is your fuel is coming from this which is rich in carbon dioxide and which is pollution is more. You must have heard that nowadays green shipping and all these things are coming, where we have net zero. You must have heard these things, that all over world that 2050 is the year where they have monitored that thing, net zero has to be achieved. In India, we have our government of India, they have in 2070 that net zero has to be achieved. So in order to achieve that net zero, there is a tremendous change, and I could say that thing, some paradigm shift is happening. What is that paradigm shift? Because everybody is talking about green, green and green, because we wanted to restrict that carbon dioxide pollution, other GHG pollution, so that our environment will be more cleaner. And how to do these things? So in that way, the burning fuel, the whatever fuel you are burning, it will be slowly, it has to be done in such a way so that your pollution has to be restricted. Pollution is mainly in the form of carbon dioxide, carbon monoxide, nitrogen oxide, and other GHG emissions. So how to do these things? So research is going on in this particular field of maritime industry. What is the alternative fuel? So these alternative fuels from this ammonia, hydrogen, methane, many other things are people are thinking, and in fact nuclear power also. So now you can understand 100 years ship is running in certain kind of fuel, heavy fuel. Now it is essential that they have to build a ship which will be running in other alternative fuels like your methane or hydrogen or ammonia or even nuclear power. So now you can understand that everything will be changed. The same engine which was running in the heavy fuel will not be able to run in the other alternative fuels. Now the question when it is coming, that it is starting from this engine manufacturer, starting from this other regulatory bodies, that how actually they will be developing some kind of a engine which will be running in this alternative fuel. So this era is a very beautiful era in the shipping industry, and we are fortunate, we are observing that things, and we are actually associated into that research to understand what will be the alternative fuel which will be ship will be running to make it more greener. Now the moment it is coming, it is very easy to say that thing, but there are lot of risk will be involved, lot of safety will be things needs to be looked into. That is the role of the classification society, that all this risk needs to be mitigated and safety needs to be adhered in order to comply that thing and change that paradigm shift from old era to new era, which is the green shipping. So same thing, when we are able to do these things, this is still running and this is not yet built because things are going on. We are involved in the many meetings, many joint research project where actually engine manufacturers, shipbuilders, owner, many, and it is not only that thing, engine manufacturer, you can understand that who will be producing such kind of a fuel. So they are also involved. So here actually entire huge industries are involved to understand how to change that things from this traditional shipping to the green shipping. So here classifications society's role is very important. Those who are looking into from this safety aspect, from the risk aspect. Now my only understanding is that thing same model can be adapted into the other industry, and so that safety can be looked into. So this is the few points I thought that thing I will be just giving certain examples, and I thanks Mr. Mondal, Dr. Mondal. In fact, had I been, I did not previously participated into such kind of a presentation. Otherwise, I could have prepared certain slides. Actually, it would have been helpful to this industry to understand how actually the shipping industry runs and why it is so much regulated, and why I mean to say I'm not saying that thing here accident is not happening, but you can understand millions and millions vessels are running internationally, but how many accidents are happening? So here accidents are not happening much because it is much regulated. And when it is regulation, when it will be coming from all over, from the government body and from the classification society or the third party agency needs to be involved to maintain that thing safety so that that can be regulated. Thank you very much for giving me an opportunity. And hopefully I can join in some other in near future some other seminars also.
Thank you, Dr. Samanta. And now I request Mr. Suresh Kumar Gupta, MD Crane Manufacturing India Private Limited, to take over and start his lecture. Mr. Gupta, please.
Yeah, good afternoon. I'm audible?
Yeah, you are totally audible.
Oh, welcome to everybody. Good afternoon. I heard about this Dr. Abhindu and Pankaj Vishwas. They were very specifically talking about one gentleman about the welding on the other fellows vessels and all that. I am from engineering industry, and our notice. Amitabh told me, so I put some line together and want to put forward to all of you. It will be totally generalized on safety. Normally, everybody knows that every walk of life have the safety, which plays a very big role. There are 4 types of industrial safety hazards: physical, chemical, biological, electrical. Physical hazards occurs when working area is surrounded by so many different atmosphere, like radiation exposure, extreme temperature very high or very low, leads to the heat stroke or exhaustion, etc. Another is noise level. When very high level is there, it damages your ear or can lead to the higher stress level and reduce the productivity and other ways. Another area is the chemical. Chemical has dangerous reflex exposure to hazardous chemicals. Presently, approximately 20 million workers are encountered chemical in our India. But because of the government regulations and all that, it is getting reduced day by day. And we are very happy that most of the industries, because they know the repercussions, so they are taking quite a lot safety measures. I will come to that also. Another is a biological hazard. When hazard comes from living organisms, whether these are tiny or virus or comes from animals, this affects our normal working day. And illness from bacteria, fungus, etc. So these are the few things which I want to put. And the last one is electrical. Poor maintenance electrical equipment, short circuiting poses serious hazards to operators. Underside cables, loose connectors adds fire to safety of mankind as well as plant and machinery. So these are the 4 which I wanted to put together, the area where normally the safety measures are required. Now I am talking about general safety. As mentioned earlier, safety is a must in every walk of life. Road safety is another concern today. However, here we will be talking in detail about the industrial safety, especially in engineering industry. Safety hazards start from the employee work due to following reasons: shock from electrical equipments, slip on flooring, falls from the working on height, accident while working on different machines, especially heavy powered machines, unprotected guards, overloaded machines. Today, the concept of safety is taken by the management with a very serious note. These are number of preventive actions which can help in avoiding accident up to 90% or more. Once you understand the types of risks your worker may face, the following measures can be taken to prevent any accident. Personal protection equipment, like by providing proper industrial shoes, by providing suitable dress, goggles, hand gloves, helmets, etc. Regular training to workers. This is another area very important. There must be some senior supervisor, dedicated person who can give proper and suitable training to the workforce as a regular interval. In India, majority of cases fatal accidents take place due to carelessness, lethargy, and sometimes overconfidence. It is where the training plays a very big role. Another area is maintain electrical equipment. You can avoid if you are able to maintain the poor maintained electrical equipment poses serious hazard to workers at every level. Regular servicing of electrical equipment and cable connections, which is major cause of short circuiting, leads to the serious accident. Fire safety. Fire safety is the set of practices intended to reduce destruction caused by the fire. There are some common fire hazards like kitchen, pantry, leakage of LPG or short circuiting, overload electrical system, short circuiting, combustible or storage area, smoking, cigarette, cigar, weed, etc., leakage and defective batteries, which can cause to the fire hazard. There are so many other areas where fire safety is very, very important. Therefore, here again, regular training and time to for mock drill can prevent maximum possible accidents. As a supervisor, you need to convey safety instructions to your employee as under do's and don't do's of safety instructions. While giving instruction to your supervisor, do's: be specific and confident. Repeat the instructions. Place posters and instructions on right place. Don't do. Don't use so many signs in one area, which confuses the whole thing. Don't use posters as a substitute or complete safety. You have to be practical. You must go through the mock drill time to time. Finally, in nutshell, as mentioned earlier, the following action must be continuous process, providing proper gadgets to the worker like shoes, goggles, gloves, proper dresses, helmets, etc. The second important is preventive maintenance of machines and especially electricals and other electronic items which leads to the various unsafety or serious hazard items. The last one is the proper and regular training to worker and mock drills as and when planned, and there must be proper insurance by the company because we are in the middle industry. People avoid the insurance and other things. But the insurance of your company and the worker is a very, very important aspect in case if the safety is hazard is ignored or some problem can accident take place. These are the insurance will come to protect the owner and the worker. Thank you very much. God bless you all. Thank you.
Thank you, Mr. Gupta. Thank you very much. Now I request Mr. Sahadev Khatua, ex-MD Odisha Hydropower Corporation Limited and ex-GM of NHPC, to deliver his speech. Over to you, Mr. Khatua.
Thank you. Good afternoon to all of you. We have a Lawrence speakers. We are listening since last 1.5 or 2 hours. And especially I will speak about the hydropower projects, how the safety aspects are taken care of, and what should be done, and how we would have acted on the recent floods that damaged Tista 3 dam and other some damages in NHPC dam and other places, and similar thing that has happened worldwide. See, this safety is the major thing which should be taken care of in the life cycle of a project, whether it's a hydro project, even if it is in the investigation stage, whether it is during construction stage or in the operation stage. And in every stage, the safety aspects should be tackled in different manner. Main purpose is how we can have lesser damage to stakeholders, whether it is a worker, whether it is a owner, whether it is a major contractor who is working on it. This safety, if I go into detail, it can be managed, it can be minimized, and safety can be shared. Shared means it may be by the worker, it may be by the owner of the project, it may be by the stakeholders, it may be by the neighbors also. Sometimes we see when some people trespass through the project, some accidents takes place. It means whoever passes through it, whoever is the stakeholder, whoever is the working or moving around the project, they should have those aspects, safety aspects inbuilt on that. Similarly, safety can be transferred or accepted. If I don't transfer or take care of the safety, then I have to accept it. The damages which will happen, we have to accept it. It cannot be ignored. At this stage, as my previous speaker was telling, the safety aspect in 70s, 80s, we have seen in the early 90s, the safety aspect was there, but it was not properly built in. It was not in the, you can say the people are not observing it properly. But nowadays, the major contractors, the stakeholders, the owner, they bend upon proper safety aspects to be maintained, to be managed by the contractors and to everybody there working there. And in another risk manager, how to manage the risk management or the safety management, we have to identify in a project what are the safety aspects that everybody should take care. What are the safety aspects for a worker? What are the safety aspects for a person working under a tunnel or in a flooding situation or in a dam which has just started or the foundation has been excavated? Those are to be identified. Then a safety analysis has to be done. If I don't take care of the safety, what is going to happen? How it will affect the morale of the people? Suppose some casualty takes place, then how it will affect the morale of people? How the project cycle would get delayed, project completion would get delayed, subsequent to it, how the cost of construction will also get delayed. Similarly, and we have to find out the risk or the safety potential, whether this particular activity has low safety potential or medium safety potential or very high safety potential or very, very critical potential. Accordingly, every stakeholder should have some guidelines to take care immediately or in a planned manner or in a phased manner. Those are to be taken care of. Since there should be safety response and planning. If it is very, very high critical safety aspect, we should respond immediately. That has to become in our total working. It should be there. How and who are the people to respond in that immediately? Like we see a particular building is on fire. Nobody waits for that. Immediately if there is a fire service is there, they immediately act upon it. Like that, where the immediate response is required, where planned response is required, that has to be identified. And those safety aspects should be monitored and controlled. Those are the things, it should happen throughout the life cycle of the project. If it's a hydro project or any other project, it should be throughout the life of the project. What I have seen in my 36 years of experience in hydropower, nowadays, what are the safety aspects being monitored, being done by the contractors or the owners or the stakeholders, they are very, very careful of doing these things. They are bent upon implementing those safety aspects so that no accident takes place, no damage to the work takes place. Those are things which was not there about 30 years back or more. Those things. Similarly, coming to the aspect of what Gosab has told, whether we can use artificial intelligence in monitoring and in operating some hydro projects. Yes, it can be done with the, I am not very expert on that, but it can be done. As has happened in Tista 3, had all the gates been open, or Tista 5 of NHPC, had all the gates would have been open, the impact of this destruction would have been less. It would have been much less also. What happened? Because some gates could not be open, and that is because once there is a guideline, proper guideline is there. Every gate must be checked before monsoon. Checked and made ready for use before the monsoon. And what are the water level? Joshi Sahab also knows very well, and he has given us a lot of guidance during our stay at Tista 5 or Rangit. He has guided us all around. The flood level, our water level in the monsoon should be at MDDL, minimum drawdown level. If you don't manage that, any flood coming to the reservoir, it has to overtop. Because your time taking to open the gate and the time the flood comes into the quantum flood coming into the reservoir may not match. That's why we keep the water at a lower level. We continue generating the power, but at the same time, we keep the water level of the reservoir in monsoon at a lower level, that is MDDL. So suddenly any flood coming, there will be cushion of time. By that time, the operating staff can act upon and open all the gates. But at the same time, what I would like to say, you think about 30 years back, 40 years back, the climate effect was not so heavy on us. Whether this glove effect that happened in North Sikkim or in many other places that may happen in Himachal Pradesh, it may happen in Uttarakhand, those places, whether we are taking those in our planning or not. And whether those effects can be taken on the planning. It may be very difficult to take those effects of glove on our hydro projects. As Joshi Sahab told in his speech, we can have no-go area for hydro projects in a particular level and above. That has to be decided. So that any effect of glove can be minimized, can be controlled by the projects which are constructed below that level. We may not have those openings to take care of all the flood coming because of glove, any damage to the lake or something like that, sudden damage to the lakes because of glove. But if we make the projects at a distance place, then by the time water comes, we can make a capacity of our gates to release that water. That has to be taken care of. But nowadays, because of this climate change and effects of climate change, as you can see recently in Dubai, they have never seen such type of flood what happened there. Whether in future, whatever project we are going to build, whether those climate aspects we can think of, this type of rainfall, this type of flood will come in the project, in the river, and we can build projects within our economic value, so that the cost of the product can be sold at a rate, like electricity we are producing at a rate of 3 rupees or 4 rupees or whatever we are purchasing, whether it is based on the market rate, or we have to design the project to take care of those excess rainfall or excess flood because of climatic change. It has to be some, we can say, we have to make a compromise on that. How much we should spend on making arrangement for that flood to pass through our gates, or at what cost we should produce our electricity in hydro projects. As can be seen few years back, 2 or 3 years back in Libya, 2 of the dams got collapsed because of heavy rain. They have never experienced that about the rain, and about 20,000 people died there because of 2 dams concurrently collapsing because of heavy rain and subsequent flood on that. This may happen in coming years. As you see, the temperature of global temperature is increasing, this irregular rainfalls, floods happening a particular year, in some other year floods are not happening. Those things, how to take care of those things, it is a thing of the debate, and all of us, all learned people, experienced people have to make brainstorming on that. Whatever will coming years, what will happen in the coming years, how we can take those things in our design, take into our construction, take into our operation of the projects. But Gosab has really told something there. Our operation team should be well trained to take care of these type of extreme effects. Once that particular project has been constructed, based on design 10 years back or 20 years back, based on the effects or climate 10 years, 20 years, 30 years back, now is the time how our operating teams should be trained. Proper knowledge, they should have proper knowledge so that the effects of those extreme events should be minimized. As our predecessor has told about whether there is a system of checking our projects or not. Yes, that system is there. CWC, under the CWC, that dam safety team is there for different projects all over the country. They periodically go to different projects. They see that whether all norms of maintaining those dams or maintaining those projects are maintained properly or not. That is being done since last 10 years or 12 years. This is being done. That's a good thing. And this needs to be done. And the safety aspects of all the projects, hydro project or any industry or anything, should be paramount importance for the stakeholders, the owner of the project, the government, and the public also. And we should see that those projects maintain bare minimum safety standards for running and maintenance of the projects. Thank you.
Thank you, Mr. Khatua,
Thank you.
for your presentation. So, may I request Mr. Achinta Kumar Sardar to start his speech?
Yes. Good afternoon, everybody.
Yeah.
I'm grateful to Mr. Amitabh Ghosh and Mr. Arunav Dattagupta for giving me an opportunity to say something on this seminar. Actually, I will speak basically safety aspect in the steel industry and in the construction sites. So in steel industry, I have been associated for a very, very long time. And in fact, our childhood has also been spent in the steel environment. So I have seen, I'll just try to relate some of the very, very sad incidents or accidents that I have seen right from my childhood in the steel industry, which are very painful. And of late, of course, there have been improvements in safety standards. There have been a lot of, interventions how to increase the safety in work practice. But still, accidents are happening. Are you able to listen to me?
Yes. You're loud and clear.
We are able to hear you.
Am I not clear?
Yeah,
Am I not
Mr.
clear?
Sarkar,
It is clear. It is clear.
You are clear. You can continue, please.
Okay, fine. Thank you. So what I would like to say first of all,
আমি যেটা ডাউনলোড করেছি যেটা বনি পাঠিয়েছিল
I have
সেইটাই আমি আবার ওকে পাঠিয়ে দিয়েছিলাম
Mr. Dattagupta, you are being hard on the screen, please.
Yes, you have to mute yourself.
Okay. Now I would like to share my experiences, very painful. One was that in those days where ISCO Burnpur used to be worked with open earth furnaces, there was a failure of one of the hooks of the ladle carrying the hot metal. And the entire hot metal spilled on the stage. And the entire stage got melted. And whoever workers or officers were on the stage, they all fell down and totally got burnt. So there were at least quite a number of casualties, an equal number of burn cases. Very, very sad case. That is one that I have seen. And of late, we have seen one accident happening in Vizag steel plant. While commissioning one of the plants, there was an oxygen leakage, and that oxygen had exploded, and it had taken the life of at least 7 or 8 executives. I don't remember, out of which 2 were from Dastur and two were from Vizag steel plant. That is also a very, very sad story. So even now things are happening. Even of late, there was an incident in one of the SAIL plants of one of the plants of SAIL, where there was an explosion because of water seepage in the in the LD converter, and 4 or 5 people got burned very heavily. So these are still happening in the steel industry, which is very painful. But I would like to again go back 20 years ago. I had the opportunity of attending an international seminar by IISI on steel industry. And there, out of 3 days international seminar, they had dedicated 1 full day for safety aspects in steel industry. So that is the importance the international community is putting on safety in steel industry. So I don't know, in our country, I don't find any seminar where some sessions or some days, I forget, some sessions also being dedicated to safety aspect. I think that it is high time that we should put this in our agenda, and it should get proper importance in the industry. Because one life lost is really life lost. Even some limbs, if they get damaged, then also the person get totally destabilized in his life. So this is a very, very important aspect, and I hope that these things are being taken care of at a proper level. Of course, accidents they have been reduced to a great extent, or as on today. But even if something happens every 1 year or every 2 years, that also is an accident, and those are taking lives. I have seen cases in our East Coast Steel plant where the plant was very old, I agree, but there were a lot of leakages used to come from blast furnace where carbon monoxide was getting leaked somewhere, and some workers during night shift they got poisoned and they were hospitalized. Similar cases had happened in coke oven battery also. But these are the aspects which can be very well taken care of if proper vigilance is taken against this area, in these areas. And I hope that many things have still to be done. And whatever is happening is because of sheer luck and maybe blessing of God that something more is not happening. But I feel that more and more attention is required for safety in the steel industry. As I am talking about steel industry only because I have spent my life in steel industry. And coming to construction, in construction site also I have worked with Tata projects for a few years, and where I was overseeing a large project in one of the steel plants. And there I have seen that proper importance was being given to safety. And for every review meeting, there was a presentation on safety aspect for the last 1 month, whatever has happened. Very fortunately, the project where I was working, there was no single mortality. Of course, minor accidents were there, but single mortality was not there. So it was a very lucky project. And I would appreciate Tata organization. The Tata projects used to take special attention towards safety. I mean, if there is even one mortality in someone's project site, that project engineer used to be taken to task, and his career, there will be a spot in his career. So that is the kind of importance which Tata Group is giving for safety. I hope across the industry this kind of practice is followed, so that there is no loss of life at any point of time. So I feel that our focus should be more and more on safety. And one more incident I would like to relate is another great incident in our country, with the Chasnala disaster. In Chasnala deep mines, where mining was being carried out maybe quite deep, maybe 1 or 2 kilometers down below. There was a intervening wall inside the mine. It got burst, and there was an old mine where water was accumulated, and that entire water spilled into the working area of that mine, and more than 300 personnel were killed inside the mine. That's one of the saddest incidents and largest accident which have taken in the mining industry. Why mining industry I'm relating to? Because Chasnala Korea belonged to ISCO Burnpur. So that's how it got connected with the steel industry also. So I understand in the mine later on in the mining of open cast mining or maybe deep mining, Coal India has taken very good measures so that accidents are minimized. But this kind of accidents used to happen, and I really feel very sorry about when I think about that. And that also is a lapse of vigil, that what kind of precaution should be taken so that we don't confront this kind of accident. Once this happens, there is no way this can be corrected. That the loss is loss, a huge loss for the nation as a whole. For the company, of course, is there, and nation as a whole, it's a very big loss. So I would, from my personal point of view, is not only in steel industry, as it has been highlighted for hydro projects, for power projects, for shipping industry, everywhere safety must have its own place, and proper safety training, safety precautions, and safety checks have to be there. So with this I'd like, this is the general thing that I have told you, my experience of safety in the industry, but I find that still there are lapses, and lots of things need to be done so that it becomes absolute zero accident industry. Thank you so much.
Thank you, Mr. Sarkar. You had a very crisp lecture, and I'm sure everybody has learned from this. And I now hand over to Mr. Anirban Datta for the remaining part of the session to continue as an anchor. Over to you, Mr. Anirban, please.
Thank you, Mr. Banerjee. And really, we all had witnessed a very enriching session with all of our eminent speakers in the inaugural session and the main session 1. Now we move on to the technical session 2. May I now request Mr. Amol Sengupta, who is by profession is a mechanical engineer and expert in material handling for mine, power, steel, and mining sector. May I now request Mr. Sengupta to start his deliberation. Mr. Sengupta, are you? Yes.
Am I now audible?
Yeah, you are audible.
Okay. Good evening to all. Hello. Yes. Good evening to all. I am indeed grateful to Amitabh for giving me an opportunity to share my views with you in this seminar. Today's agenda is safety overview in all various industries of engineering and infrastructure sectors for measure of present status to ensure the total safety. I strongly feel the illiterates of 21st century will not be those who can't read, write or express, but probably be those who cannot learn, unlearn or relearn their core subjects for updating the knowledge with advancement of technology in this developing world. Conception of industrial safety. Industrial safety has come a long way since inception of safety movement in 1911 on a tragic fire creation of world's first safety society American Society of Safety Professional, ASSP. This body first starts working on safety practices for the workmen and then implemented it to all the industries in corporate and legislative levels. It is the concept of total industrial safety and prevention of accidents. In this procedure, the industry provides safeguard to its employees and assets within industry by minimizing incidents of risk, hazards, accident on the laid down safety management procedures. The three essential ingredients in any organization are man, machine, and material. These form the three angles of a triangle with management at the center to control them for maintaining the equilibrium. Machine and material flow can be programmed and controlled, but man neither can be programmed nor controlled in a democracy of globally of our material society. Industries require is zero tolerance accident. Why safety is required? To prevent all the accidents. Can safety be prevented? All accidents? The answer is always depends on the measures of hazardous incident causes for the accident. Hazard, risk, accident, and the chance of incidents are the main cause of disturbance in the industries. Hence, human touch on safety management system in workplace can only prevent the disasters and accidents. However, all the components of accident and disasters in with reasons thereof are not saying or describing here due to time constraint, but the details with causes on all the parameters are briefly elaborated in the slides of my presentation. All the direct and indirect cost of accidents are covered under the insurance claim against losses. So the measures of safety is introduced to prevent all the losses as such. Ultimately, safety performance is the matter in the workplace. How to achieve safety? Safety is broadly grouped in 5 E's. Engineering for process control, enforcement for rules and procedure, education for training, enthusiasm for behavioral aspect, evaluation for audit and mock drill. Principle of safety management. Unsafe condition and accidents are only symptoms of something wrong in the safety management system. Safety should be managed on top priority function. Safety performance key can fix the accountability. Safety equipment and PPT are required, but a trained, alert, and safe man is more important and essential in any of the industrial disaster prevention program. Today's thinking on industrial safety, accident does not happen. They are by cause of mainly human, mechanical, and environmental. Accident not happen simply due to technological or human failure, but the failure are responsible totally for safety management control system. Accidents are mainly due to uncontrolled events and activities for the incidents. Safety is a management function to control all the events and activities. And objectives and critical reasons of safety, avoidance of accident, cost saving, increasing productivity, environmental impact, overall moral boost up, legal compliances, and solidifies the reputation. How safety can help on industrial software. Today, in modern world, with advanced technology, develop computer controlled machinery, robots, and artificial intelligence driven safety equipment that are entering in the workplaces for enhancement of productivity and reducing the unforeseen accidents. With advanced software, companies can streamline the work for employees' well-being, reputation, and saving of cost to ensure new safety culture. Therefore, my conclusion is full 100% safety with zero tolerance is really not possible due to human error and negligence. Even the processes are well laid down. It is often practically not happening for some intentional or unintentional activities. Moreover, it is obvious that the senior citizens observed during their past working experience in the different field of industries for actual reality of safety status on workplaces in each corner of the world. So, to make it stringent and mandatory, achieve 100% safety and accident-free industrial working environment, then safety norms to be linked with the insurance benefit. So that if a victim not meeting the 100% laid down safety norms, then the victim or any of their legal heir will not be entitled to receive the accidental benefit by law. As such, nothing is possible to implement strictly in our democratic society if it is not linked with the financial benefit prior to any of such incidents and accidents. It is the reality of our human psychology in this world. Presently, industries are using the artificial intelligence and the robots with advanced technology. So I am hopeful in future to achieve the zero tolerance on land for safety to prevent all the accidents and incidents at the workplace in each part of the world. Thank you.
Thank you, Mr. Shengupta, for your lucid presentation and sharing your personal experiences also. And I now request Professor Tapan Bakshi, who has joined from USA, West Virginia University. He is a mining consultant and very renowned figure in the field of mines and mine safety. May I now request you, sir, to kindly start your deliberation?
Good morning, and my name is Tapan Bakshi, and I'm going to talk about certain experience that I had in the coal mines, and and I'll also suggest the precautions to be taken after that incident. One day I was in the coal mines, and I had there was a phone call from outside. There is always a man outside the coal mine. So he called inside and said that inspector has come. Now that's an indication to the coal mine operators or coal mine owners that you take care of everything so that nobody can find any mistake in the coal mine. So they take care of the things like putting a curtain, building up the stoppings mean the wall of the brick wall. They hurry up and do that. And then in the meantime, about an hour passes, and then the inspector goes inside. So because of this situation, a lot of things are not taken care of. One of the way that we can do that is the inspectors can carry with them. They can carry with them a golf cart, and they can drive themselves in a golf cart without any permission from the coal mine. And that way they can check more, and nobody can take care of the faulty things, and they can inspect that and show the citation. That will give some better safety. Another way also we can do this is third party inspection. Normally the mines are inspected by the federal government and also state government. And if there is a third party inspection, how can you do the third party? That you can ask another coal company to go and inspect at random without any notification, and they will be given the power to do that. So that way, these are the two ways you can do the better safety checking. That's all my presentation is. Thank you. I'm done.
Thank you very much. That was quite insightful.
Thank you, Mr. Bokshi. Actually, in my past experience, I have seen lot many accidents in steel industries and others, but this prevention measure or preventive measure mainly I have seen in my practical life that Tata Steel, which I think all other industries should follow. Because in Tata Steel there is, you cannot say there is no accident, but there are accidents, but there is not major this casualties. Particularly when this, that was of course not in the industrial this operation, but it was an accident due to during this 150 years of Jane Tata's birthday. There are
Yes,
accidents in steel plant.
you are absolutely correct. Definitely Tata Group has set a benchmark in the ensuring the plant safety and operational safety. And we are really thankful to Professor Bokshi for hearing from him, and he has really focused a deep insight on the mine safety aspects. And he has joined from the USA, and we again express our sincerest thanks to him.
Yes, I have seen. I have just seen.
I would like to interject one more point about this. There was a big fire accident, big explosion in a coal mine because there was a man door open. Man door is a door, small door. Every 5 stoppings, you keep it opening. And because of that, there was a big accident in the United States. So those are the things, very small things, but if the inspectors can catch it or the coal mine operators can catch it and do it, then the chances of accident will be very reduced.
Thank you, sir. So, as Mr. Sengupta has mentioned about the safety practices of Tata Steel and Tata Group as a whole, we are now having the next speaker, who is actually a former Tata Steel personnel, Engineer Pritish Kumar Sen. He is ex-Tata Steel, and also he is the former head of INSDAG, and presently he is heading the Steel Tech. So may I now request Mr. Sen to start his deliberation.
Yeah. Thank you, Mr. Datta. Am I audible?
Yes, you are audible.
Yeah, thank you. Thank you once again. A very good evening to all fellow panelists, ladies and gentlemen attending the seminar. At the outset, let me first congratulate IIT Guwahati Technology Innovation Hub and the GVS Energy for organizing an online seminar on the safety, which is not only very, very important topic, but quite often neglected in many places, if not all places. Here, let me mention, if you talk about India now today, we are the fastest growing economy in the world. We are fastest growing stock market in the world. We are fastest growing startup ecosystem in the world. We are fastest growing real estate in the world. In 2014, we are the 10th largest economy, and now we are the 5th largest economy and going to be 3rd position if if the IMF and all say if the growth rate is about 6 to 7% in GDP, we can. But let me say our safety records are very, very poor. What our previous panelists, they mentioned, they can give excellent presentations. It is showing. So in my presentation, I'll not mention anything about it, but I'll just mention some of the general thing which is there and it is to be followed just to sensitize. This is because it was not ingrained in our culture, but we have to do it. I shall give you a very few example, even a very common one. When I joined the industry long back, now people used to give more attention to the production unit, to the rolling mills who are going. I was, as you mentioned, I'm from steel background, Tata Steel. I was there about 35 years more. So there, when during our training, the people, if they come from steel, steel melting shop or rolling saw, people used to give more attention because you need to learn from there. But when it comes to, safety also was there, people used to take little relax. They used to feel that maybe it is essential the way the personnel department are there, they have to give. Similarly, they have given a safety. But it is no more there. The scenario, however, the scenario has changed. The safety situation at this level today, because it is not ingrained, as I mentioned before, I shall give a very common example, not from the industry at the moment, a general one. When I become the first grandfather, because of when my niece became a mother in Houston, USA, when the child, it was releasing during that time from the hospital, they did not release the child till the time they get a cradle, and that child is to be put in the rear seat with the safety belt on. And in our country, even in India, it's a great ceremony. The grandmother or somebody elderly person carries the child and enter the home. But it should not be done. A child during the travel in the car, he must be there in the rear seat. But in our country, no, আমি সামনে বসবো, nowadays, of course, because of the AC, আমি side seat এ বসবো. When we are child, it used to be there. But it has to be followed. If they know that this is to be done right from their childhood, it ingrains into their habit. It becomes a habit for them. Now, I shall give you a very general observation. While I was in Tata, I was there involved in a World Steel Association. There is a Living Steel Consortium. We are going to have a construction here in Kolkata. That's a international, winning steel building. And one lady architect was coming from Europe. So I told my office, please send her a card and please ensure that, there is a safety belt. A safety belt has to be there. So I got a call in the midnight sometime. He said, Pritish, there's a safety belt, but the knob is not there. So I was a little furious about my admin department. I told them, what is it? No, sir, we have sent a new car. The new car was sent, but like in the rear seat, they put a very nice seat cover, but they did not take out that, safety knob where the belt will go. Because that time in Kolkata, putting the safety belt was compulsory in the front seat. Police used to catch if you have not put the safety belt on in the front seat, but rear seat is not given. But it is actually, they cannot travel without a safety belt, So that culture has to come. You also remember the very sad incident in the month of September 2022, where we lost Mr. Cyrus Mistry. He was in a very, safe car, Mercedes. It was having 7 airbags and all. It was found that safety belt was not put. Very sad incident. But this is the one what I'm saying, because, it has to be sensitized. And now I give in some example. When and India is now, as you know, we are the rank almost first or second in the road accident, and 15 to 18% deaths are there. And this is mostly because of young lads driving the car without any following the norms or many things like that. Even Nitin Gadkari mentioned once that he is a failure in this side because he's sensitized, but people are not observing that. So we now have to have very sensitive for this. I shall give you some, example for my industry own life. 2005, I was going abroad. I was in Delhi, and that time we had a talk with Tata BlueScope Steel. That time BlueScope Steel and Tata Steel, they are negotiating to come to a company. Now it has come out as Tata BlueScope Steel. So that time BlueScope Steel office was in Delhi. So they invited me to go to their office, and there was a quarterly report for this. And they did fantastic well. They did a lot of profit was there. When they invited me for the presentation, they're doing it in Australia. It was online, live that side. I was surprised to see the first slide, which it came. And that time, I also mentioned this to my MD, Mr. Muthuraman was there. I said, sir, do you know what was the first slide on there? PK, he used to call me PK. I know they made a huge profit. I said, no, sir. The first slide, it came about the safety. That why I said that, because the chairman, when they're giving the presentation, the amount of importance they give, it is not only that you have a safety department, they'll take care about this. It is not so. It must be there from the top. It should come down from the top, because the top management is taking that. Of course, Tata's, somebody mentioned like Mr. Sarkar and others, they mentioned about like Tata takes care, but definitely, but it became more sensitized. That time, Mr. Muthuraman and the others, they also insisted on safety and safety. While attending, I'll give you an example why the people abroad, they're so sensitized. I was attending a meeting in the Shanghai, and a fellow colleague was I was on the secondment from Tata Steel. fellow from, again, Blue Scope Steel was attending that seminar. It was in the 7-star hotel in Shanghai. And it's a newly inaugurated hotel. It's a beautiful conference room with the Sinclairs on the side. We are in the front. And, at the back of it, one Sinclair just fall. And I found that fellow Michael from Blue Scope, he was writing something. Or what are you writing to? He said, no, it is an incident. I have to report to my office. I said, what are you? Well, this has happened during the meeting. I have to report. So he sent a message, and he was asked to leave the conference if the conference room is not changed. And Scott Chubbs was the director of Living Still that time. He organized, because this is the meeting has been organized, say at least 6 months before. They fix up a room, they fix up the hotel, and he said, no, it has come to my head office to leave if you don't change that this conference room, I cannot attend. Mind it, he came all the way from Australia to attend the meeting to China, but he left the room, and then Scott Chubbs changed the room with discussing with the hotel people, and then he attended. Why I said this? Because this is the importance they give. It is 7-star hotel, it is a beautiful hotel, but there are some flaw, but it cannot be tolerated. So that is the sensitivity it is given to. Now I give a very common example. Somebody mentioned about the Tata Steel is being followed. It is definitely followed, in plant, safety shoes, helmet, blah, blah. These are the very common. Even the contractor worker has to follow. Even then there are some accident, but their management is very sensitized. Even we are more sensitized, when you are using the stairs, like suppose you are using the stairs, there are safety drills and all. Even otherwise also, in a stair, it is seen like 80% of the accident in the staircase is because of not holding the handrail. So it is compulsory. Suppose you go to Tata Center or go to any place in the Tata, if you are not holding the handrail, even if you are a visitor, somebody will point out, sir, please, madam, please hold the handrail. So this is the one. This culture has to go. So safety, it is there. It has come into many places. For any meeting, before that, there is a safety briefing has to be there. It is not only before any meeting, but somebody is going to a place. Suppose we are going to Tata Center, or you are going to some other place or any other place, or you are going to a hotel also. If you do not know, like, you have to be told that you are in this area. If there is a fire, if there is anything, you have to assemble someplace. So these has to be sensitized. I found Professor Pramanik mentioned about shipping. Dr. Ashokendra Samanta, he also mentioned about this. Mr. Khatua also mentioned about in his deliberations. Mr. Achinta Sarkar, of course, mentioned about the steel plants and construction site. I remember when I was a student, I had an opportunity to having my training there in Bangalore, HAL Bangalore. I happened to be there in their maintenance department that time. I found even if that aircraft, everything is fine, they used to open and do. They said that there is a norm. Even if the instrument is perfectly fine, working fine, this has to be followed. If it is run through so many hours, so this has to be followed. If it is run for so many hours, the instrument has to be changed. That norms, if you don't put, there is nothing in that upstairs, air you can have. So if they're doing it, so they are following because there is less accident. If you not followed, there are more accident. So therefore, that sort of thing, what my previous president mentioned about this safety with regard to, shipping industry, the similar norms has to be followed. The third party inspection professor mentioned about, so this has to be followed. So therefore, I end my deliberation once again saying the safety need to be taught right from the childhood, must be a cultural driven. It is a top priority to be given by the management and also to be followed by everyone. With this, I thank you very much for this opportunity, Mr. Coulson.
Thank you, Mr. Sen. You have practically focused on the most important aspect of the safety, that is the human factor.
It's a culture, yes. We all should follow. This should be right from the childhood.
Yes, absolutely.
Thank you.
And once again, big round of applause for your sharing your practical experience and particularly mentioning the importance of safety briefing in meetings and events as well. May I now request Dr. Sarajkant Singh, the next speaker, to present his deliberation. Dr. Sarajkan Singh is the Associate Vice President of Power Plant Engineers Limited. Saroj, are you online?
You see his name.
Saroj is
Can
there.
you hear us?
Muted.
Saroj, can you hear us?
He is muted. Yeah.
I think Sarojkan Singh is maybe he is facing some connectivity issue. Otherwise, he is being seen as online, but no response from his end.
You may call the next speaker.
Actually, we have come to the concluding portion of technical session 2, and we can move forward to the valedictory and vote of valedictory session and vote of thanks. May I now request Dr. Nishit Ranjan Mondal and Mr. Arunava Dattagupta to kindly take over for the interactive and valedictory session.
Arunava.
What is Arunava Dattagupta? Yes, I am here.
Arunava?
I'm here.
Arunava, you can join.
He's there. Yeah.
First, Nishit sir, first let it be of Mr. Nishit sir. Then I will come.
It is 6 o'clock evening in the Sunday.
Yeah, we have been. We have tied you up.
Maybe sir, you have a break. He has gone out of the ballet.
Yeah. Anyway, so we have actually gone through many deliberations. Yeah. Thank you very much. I will not take much time. Sorry. Many people have spoke about aspects of safety issues. So what I find that one very important point touched upon is by Mr. Shane, Pritish Shane. That is what is that the very thing is not there in our culture. That is the very first thing. That's very important. But it's here we are here. It's difficult to. I mean, it's good to know, good to be aware that it's not there in the culture. Experience is shared. I will also like to share the similar experience. Quite some time back, that time we were organized. I mean, we have a series of conferences. What ICSOT, International Conference on Ship and Ocean Technology. So Trevor Blackley was coming. He is the CEO of Royal Institution of Naval Architects. We do it jointly with them. So same experience because it happens in the December night. I was in the bed. Suddenly I get a call, and it's Trevor calling from Calcutta Airport in the night. His flight was there in the night. So I said, "What's it? Everything's fine, Trevor." Say, no, not exactly. I said, why? What went wrong? The card is not there. Card is there, but no seat belt. Imagine. I'm talking of 2007. 2007. In 2007, I'm not very sure whether the front seat was taken, right? So the back seat, no seat belt. He refused to board the car. Another car had to be organized, sent, and then only he came. So same thing. He's a Britisher from England. Is coming. He said, "No, I cannot go." So though the driver tried to explain, sir, here it is not necessary in the back seat to have a seat belt or not. But that's not important. Is that culture of safety. Same thing. Somebody told. My memory is becoming poor. Somebody talked about jugaad, right? We have that mentality of jugaad. Yeah. This Mr. Bolas Joshi only. Yeah, you have only said the jugaad. We have that concept of jugaad. Ho jayega. So, we'll do it. So the moment we have that kind of attitude, well, accidents and what, that means we are basically compromising on safety. Safety is a thing which not only, as my understanding and also from the deliberations from everybody, I can feel that we all agree to that point, that safety is not only like I'm operating the machine, so that time I have to, have the proper suit and all that for such that happen. It's not that way. That machine is being operated for some production, that for that production some design drawing has been done. So it has to start right from there, what Dr. Samant has mentioned. I mean, that is how we do it in shipbuilding. Right from the design stage, the third-party inspection comes in. Third-party inspection is for what? Essentially for safety. Why? Like you may have understood from his talk that unless until those are not followed properly, the certification will, drawings need to be approved by them that okay, it has been done correctly. It's not enough. After that, you will do the material procurement material at the same time, material procurement. Materials are to be tested, certified by the classification societies. The material is of the correct, what you have mentioned in the design. Production process, welding, cutting, everything, continuous inspection. Unless that is done, you don't get certification. If you don't get certification, you cannot fly. The vessel is ready, but you cannot use it. Why you cannot use it? Because port authorities will not allow you without insurance. Insurance company will not give you insurance unless there is a certification from this third party, authorized third party, right? So there's a huge lot of, right from the design stage till, and then operation. When it comes to operation, like somebody has said, that even was saying, anyway, that yes, the auxiliary machines did not work. Probably Mr. Khatwa was mentioning that gate in some dam accident, this 5 or something, the gate could not be opened in time, right? And Niranjan, Mrs. Maha told in some power plant there's a accident. Why? Because the auxiliary, there was a power failure, the standby machines did not work. Why? Because they were never required, they were never tested, never checked. But in shipbuilding, when a ship operates, after everything has been done, now it's in under operation, there is a mandate from the classification society that periodically they will come and check all the systems, lifeboat. In the entire ship's lifetime, maybe their lifeboat will never be used. God save that it's not required to be used, right? But that doesn't mean that we will not check the lifeboat periodically. Physically, you have to do the dropping of the lifeboat, testing that it drops correctly. Because there are instances, 2 days, 3 days, 4 days, 5 days, 6 days, 7 days, 8 days, 9 days, 10 days, 11 days, 12 days, 13 days, 14 days, 15 days, 16 days, 17 days, 18 days, 19 days, 20 days, 21 days, 22 days, 23 days, 24 days, 25 days, 26 days, 27 days, 28 days, 29 days, 30 days, 31 days, 32 days, 33 days, 34 days, 35 days, 36 days, 37 days, 38 days, 39 days, 40 days, 41 days, 42 days, 43 days, 44 days, 45 days, 46 days, 47 days, 48 days, 49 days, 50 days, 51 days, 52 days, 53 days, 54 days, 55 days, 56 days, 57 days, 58 days, 59 days, 60 days, 61 days Ship is I mean, some disaster has happened, some accident has happened, and they wanted to lower the lifeboat. Lifeboat doesn't get released from the rig, right? So these are that is how the safety aspect. Now, many of these hydro hydro accidents or thermal power or any other engineering mistake. Somebody talked about Chasnala disaster, Chasnala flooding. I know that because we happen to be from a mining engineering family. My father was there. So Chasnala disaster, huge inundation of the mine shaft and everything. So that is what it is. That means we'll have to have a system. And here our primary focus is, though we are talking about the entire gamut of industry, but the hydro projects. Primary focus in the hydro projects. What I have seen, I had the personal opportunity to see the the failure in the coming hydro plant. What happens? If you go and welding of the paint stock, it's pathetic. Why pathetic? Because nobody is there to check. I don't know who's the supervisor who is checking or what. So a system has to be put in place. How that system can be put in place? Well, there has to be a mandatory third-party inspection. Shipbuilding, in the shipbuilding, that's why the structural design, hydrodynamic design, these things are, I think, the best in the shipbuilding industry because they are put through so much of stringent specifications and tests. So similar concept, that's our focus. Similar concept we should be able to bring in the hydropower sector. Then what it will happen? Not only the question of what accidents, but question of proper implementation of project. Biggest example is Julia pump storage. It was completed before time. It is completed with zero accident. It is operating perfectly. Any other hydro project you see, you will have lot of time overrun, cost overrun, few accidents, and whatnot. Why? Because here Japanese fellows were there, as I have heard from Mr. Ghosh, that the contractors used to get irritated that why these people are holding it back. They are never satisfied. No, you do this. No, our project time will get elongated. I mean, we will not be able to complete it in time. No. Unless they are satisfied by each and every step, all the norms specified. Norms are there, but nobody uses them. Nobody checks on through that. So that is only possible. Not every time we need to call the Japanese fellows to teach us. We know ourselves. But we'll have to have a system in place wherein a third-party inspection, something similar in lines to the classification society, like it is done, if we can do that. And that's what we are thinking in terms of, under the Technology Innovation Hub, under that Center of Excellence have been formed. Through that also it can be mobilized. I don't know. I mean, something that can be, we can put that. And another aspect is usage of modern techniques, modern tools like artificial intelligence, so that we can, because artificial intelligence, you see, it's also important. Per se, it doesn't have any intelligence. The human mind, I mean, the human interface is only putting in the required intelligence in the system. But that is being done offline, so you can properly do, and once it is done, then that is implemented, which can take care, and there the chances of unintentional negligence, human negligence, can be avoided. Like it seems it's that happened. The gates could not be opened in time, and so on and so forth. Probably had there been a system like artificial intelligence, which will give us inputs, or it can trigger the machineries to open up. So these are the basic two things: third-party inspection, proper supervision procedure in place, and usage of modern tools and techniques like artificial intelligence to enable to implement safety aspect as much. And of course, as Mr. Sain has pointed out, that culture, that very culture, and to dwell with that concept of jugaad, absolutely. That jugaad concept is very typical Indian, I believe so. Well, at places it works, but that should not be the order of the day that you do it. Everything should be properly defined, documented. That's why in shipbuilding, you have the owner's specification, you have the builder's specification. Every line has to be followed, and there is a thorough check. People get fed up that to satisfy all the lines what is mentioned in the specification and drawn up this thick. So we'll have to do. Anyway, thank you. So that's how I thought I'll just summarize. I felt like summarizing. Very interesting deliberations from everybody. Very nice. Yes, please. Yeah.
Oh, Mr. Joshi.
If you permit, I would add one more term to it. That is the called kuch nahi hota syndrome. You tell somebody, I remember in my earlier days when I joined a project in the Jammu and Kashmir, we were working in a deep pit in a school where a proclaim was to be unloaded by virtue of a crane. Now, to me, it appeared, I was a young engineer, but it appeared to me that, probably this is going to tip over. And the reason for saying that was because I had seen other people doing it elsewhere. They used to tie a dozer behind it and pull it behind, so as to give an additional reactive force. I went to the in charge there and I said, sir, I suggest that you tie a dozer behind this crane, otherwise this can't be pulled down by the weight of the crane, and the angle at which you are going to deliver it is too flat. He says, kuch nahi hota. Kuch nahi hota. Hum bahut kuch karte rahe. And believe you me, within 5 minutes, the crane along with the proclaim, they fell down deep into the pit. So I have been telling people, don't say kuch nahi hota. If something can go wrong, it certainly will go wrong.
It will go wrong.
I have seen it happening before.
Yeah.
And
that's correct.
Yes. One more.
I would like to say, first point is that because I had the opportunity to work both in shipbuilding line and also general engineering, so I feel this system may be adopted and should be adopted. And this has never been done anywhere, not in India, and I don't know anywhere in the world. So somebody told me that nobody has done it. I said, nobody has done it does not mean we cannot do it first time. That is number one. Number two, that third party you are telling, third party inspection. But one thing is very clear: the shipbuilding, the third party inspectors are highly paid. You cannot manage them. This is very important. There is always a human factor, and because in inspection there is a common terms that he is not cooperating. Cooperating means he is not passing, this thing, cooperating. And this I am facing throughout my life. If I am tough, gussa to cooperate nahi kar raha hai, And this is what it is. In case of Purulia, so this one has to be very careful about the level of third-party inspector, very much. And I would say one example of Purulia, when we are saying, Purulia, when we got the order from Mitsubishi, I was in Texmaco head, so they made an organization chart, and there is one fellow safety officer. So I said, safety officer, special safety officer in whole life of Texmaco, there was nobody, So I said that this man will work this, and he will also be a safety officer. Well, no, safety officer is an exclusive man. I said, who do I get a safety officer? Nobody wants to be a safety officer. People who are. Then I found a man. People were not liking him, but he was a very strong talker. I said, will you be a safety officer? He said, yes. I said, then next day, Japanese said, he has no training. I said, you give him training. And then after that, he did excellent job, training. And there was no accident. No accident. It's small gadgets they make that you feel very comfortable. He said he made a gadgets for the welder, so that welders can comfortably do the inside welding of the penstock, through which they are going down the platform. He says if the welders are comfortable, welders are safe, then you have a good quality. Because as you are telling about penstock, inside tunnel penstock welding, 3, 4, 5, 6 welders going on, you will not be able to stay there for 10, 15 minutes. So bad. And there is no air sucking unit also adequate. So what happens, I'll tell you, a good welders, at the end of the day, they become fatigued. And with fatigue, the defect comes. And these welders do not want to come out because as per welding length, they have an incentive. So they don't want to go 10, 12 hours, they will work. And this is the problem. And unless you have a good and the automatic system, semi-auto system, which gives you better welding, faster welding, nobody will follow that. When I say that you use it, he said customer has not written in the contract. So why shall I use it? And Jugade, as you are telling, Jugade method, Jugade technology. So unless you make the people educated, it is difficult. And of course, the highly paid. These are the things, but this should be done. Because the people in Sikkim are telling that we do not want any hydro. Enough is enough. Why they should tell them? Why it will happen?
This is my pain actually. I have seen it happening in the same project, in Salar project, Mr. Ghosh will recall, it was done by TechSnap only. We had an upthrone system in those times for operation of the gates. And today I can confess before this gathering that this was the first flood of the project, which was almost equal to the design flood. It came when I was in charge of that dam gates. And we could save the dam only because we had the upthrone system, wherein you could feed the opening of the gates by virtue of a computer. And there was one particular knob which said all gates open. And downstream we had Pakistan, whereby we had to follow the Indus Water Treaty and decide upon number of gates beforehand, which was already agreed with them. But here was a case where we were seeing that our dams are going to be washed away. There are 2 dams actually in that project. One is a failed dam and the second one is a concrete dam. And then the person who was with me, he said, I think, brother, we should put this all gates open button immediately. We pushed that. We created a flood, no doubt, but we could save the dam. That's the whole idea of the flood. And actually speaking today, when I recall back after having gathered a lot of experience after that, I find that was a night when 2 dams could have been washed away. But that day they were not because of that automatic system we had. And my pain now here is, we designed Tista 5 dam, such a beautiful dam, a good monument. We had this kind of a system, but not the automatic control. We had all kind of manuals placed in the control room. We told our people, and we were stressing them, keep that at an MDDL. Whenever you have a warning from the upstream, open up all the gates, go down. Everything is very nicely calculated, minutely drafted, and put in the operation, but there was no automatic control. That was the problem. That was the disaster of Tista 5.
I just would like to say,
something. Yeah, Pritish.
Yeah.
Yes.
As because the time was given 5 minutes, I start to this sensitiveness has to be there. It has to be there in the culture. When the building was coming up, Scott was there in Canada, so I insisted them that people, how they work in Kolkata. There was piling going on. People will not wear helmet, so I insisted them to put. It was raining, so people were not wearing shoes. So he saw a photograph. He said, Pritish, they are wearing helmets but not wearing safety shoes. Who wears the safety shoes in the one? So they don't bother. Chalega, that's what Mr. That thing. It has to change. Other thing is, like, if you want to put a cost, then management also should know. By doing this, the cost has to increase to some extent. So there has to be, their management has to be there. If you want to be safe, maybe the total loss is not that. Initial it may be little more. They should be on that. When he mentioned about that, like shipping, depending on the sensitivity and requirement, where I mentioned about that aircraft, there is no other, you cannot do anything. So depending on that, it can also be seen if it is a very sensitive one. So there has to be something which is like which is followed in aircraft industries. So that also has to be there. So I thought that they mentioned about this. Thank you.
He raised a hand.
Gustav, I'd like to tell one thing. I'd like to tell one thing. Even the best of the vehicle in the world, if it is not a proper driver, then accident takes place. It is like to any industry, any industry.
Yes.
Whether it's a Pista 5 or any hydropower project or anything.
Yes.
It is only the operators and the head of the projects. How they are guiding these operators to operate the gates or operate the machines. It all depends on that. How safe we are.
Absolutely. Even that Cyrus Mistry died in a car, is a Mercedes car.
Yeah, you told that.
So much of it's a 7 airbags were there, 7 airbags.
Yes.
But he did not put this seat belt at the rear. He and his friend Darius, both of them had, unfortunately.
Yes.
It has to be followed. That's what I mentioned. It has to be there in the culture. As soon as you go and sit in the car, you should first put on the seat belt.
Yes.
Cutting the car. कुछ नहीं हो तो नहीं पकड़ेगा, पुलिस तो नहीं है. But that is what culture you follow. That is unfortunate, The people carry the baby. It's a great thing to carry the baby.
Orunavo? Hello. Orunavo Dattagupta will give the vote of thanks. Orunavo. Yeah.
Okay.
Thank you very much.
Sir, sorry, sir. I just want to add one thing in that. So I'm Santosh Paul.
Please do.
From representing ISSPL, because I've been invited for this, so then I thought that okay, I will give, even though all the topics have been covered by everyone. So I thought
shortage of time we couldn't accommodate. Please go ahead.
I will not take much time. So I just since I have joined the meeting, so I should be talking something about that safety. So see, I'm very much privileged to be the part of this seminar with the industry experts, which I never got an opportunity before. So I'm very happy for that, and very much thankful to the organizers for conducting the meeting today, at the seminar today. And we all spoke about 3.5 hours. We spoke about safety. Nobody has spoken about today's Safety Day special for the today. Today, April 28, is the day globally we observe as World Day for Safety and Health at Work. This is what we were talking about.
Oh, great.
See, we all talk about our experiences and everything, but today is important, because I was happy when Dr. Shogendu has told me you will have to speak two words about that also in the meeting. Then I told sir, yes, I'll be there. So then I was I presume that today's the day we selected today, maybe because of the World Day for Safety and Health at Work. So anyway, that is, I thought that, okay, I'll just tell about that, sir. So the theme for, because since we are not spoken about that, then just want to summarize the theme for 2024. That is the impact of climate change on occupational safety and health. We all talk about, I heard talking about the climate changes and all this stuff we were talking, but how it is impacted on the occupational safety and health, which nobody has, I think we have not covered the topic. So there are, climate is changing, global warming and everything is coming up. The climate change poses the significant risk to the occupational safety and health across the various sectors. It is not only for the infra, it is not only for the power, it is for all the sectors which is impacted, like extreme heat, extreme temperature, poor air quality, natural disasters, vector-borne diseases, waterborne diseases, likewise, and workforce adaptation challenges and mental and health impacts. So these all things is impacting the workforce or the culture of safety in the present scenario of the rising temperature. That's why they might have ILO might have selected the topic or the theme of impacts of climate change. So the addressing the impacts of climate changes in the occupational health, which can be done by a comprehensive risk assessments. and proactive mitigation measures and the implementing the strategies like heat stress management plan because in various industries where we are working in the kilns and other where the heat is there, not only the sun's heat, radiant heat or the sun heat, it can be the heat generated by the machinery movement of the process industries. So do we have a heat stress management plan, emergency preparedness and trainings? Do we have improved ventilation systems? So these all things are the things which we need to highlight or which need to address it as a senior members or the panelists, so that at least we can advise the organizations or the clients. So this we have to improve. We have to implement it, not by words. It has to be implemented by the physically. It has to be implemented, and of course, no safety can be followed in the industry, or let it be any industry. Let it be ship industry. Let it be I'm from the aviation industry. Mr. Pritesh Sen has told about the aviation industry. Very well, he has told that aspects, because when we do as oil filter or a fuel filter change, we used to have our maintenance manual with us. Without opening a maintenance manual, we are not supposed to do. Maybe I might have done hundreds or 500 times, I might have done the change. But that is a culture which we have to inculcate, not only the aviation industry, not only in the ship industry, it should be there in the construction industry. And it has to be led by the top, not from top. It should be from the top down, not from down to top. It will never happen, sir. So that is what which I would like to emphasize a little bit on that. And one more thing, how we, even though I'm from the aviation industry, almost 15 years I was there in the aviation industry, and I shifted to the construction industry in oil and gas, refineries, pipelines and all. So how we manage safety, that I just want to, bullet points I just learned to add in that. Like we aim for zero goal, that is called as goal zero. That means no accidents, zero incidents, or zero environmental pollutions, zero road traffic accidents. This is the target which we generally keep. For attaining those targets, we used to have the stringent measures. I was working abroad. This is the only first time I'm working in India. Otherwise, I was working almost 18 years abroad in oil and gas industry. So I just want to capitalize that the summary of that. So we used to have a good safety management system, which includes all the policies and the procedures. And we used to have a task and targets for each employee, from the chairman onwards down the line. All the key HSC key position people used to have the task and target, which is signed physically by the chairman. That is how the oil and gas industry worked there. So we used to have policies. We used to have laid down written policy procedures for each and every activity. No deviation is permitted. Beautiful operational control system like hazard identification and risk assessment we used to have. And various control measures. It is not only implemented or made by the contractor, it is being vetted, it has been reviewed by the main contractor or the EPC. It is again vetted by the consultant, like as we told about the third party, and it is then the client is accepting it. And after that, it has to be followed by sentence. No changes is accepted in the risk assessment once it is made. Yes, changes can be made because the construction industries are dynamic. Today's scenario may not be tomorrow. It is dynamic. So again,
okay, thank you, Santosh. Unfortunately, time is coming. It is short. Our people will leave. I will request Mr. Dattagupta for the vote of thanks.
Thank you. Good evening, ladies and gentlemen. It is my proud privilege to propose vote of thanks on this occasion. As the great saying goes, all good things would come to an end at some point of time, and so is this seminar. I'm sure the August House will agree with me that this had been a unique endeavor and a beautiful experience for all of us, be the faculty or industry or the participants or the organizers. Our heartfelt thanks to Mr. N.N. Datta, CEO, TIDF Guwahati for IIT Guwahati for sparing his valuable time and sharing his thought. We are immensely indebted to Dr. Nishit Ranjan Mandal, Chair Professor, IIT Guwahati Technology Innovation and Development Foundation, TIH Division, for sharing his enlightened thoughts. Dr. Mandal had been constant source of inspiration and guiding force for the organizers. We are extremely grateful to Mr. Balraj Joshi, former CMD NHPC and currently member technical of NCLT, who shared his thoughts, concerns, and suggested way out for all of us to follow the same. Thank you, sir, for your immense contribution. I also express my deep gratitude to the faculties of IIT Guwahati and also to industry experts for sharing their opinions and thoughts, which will surely be helpful for everyone involved in safety management in the country. I also explain my organizing this seminar. No words are enough to express the Herculean effort put in by Mr. Amitav Ghosh, starting for conceptualizing to macro and micro planning to scheduling and successfully implementing the same. He had been prime mover and motivator. Let's give big hand to Amitav.
Thank you.
The seminar could not have been so beautifully organized but for untiring efforts of Mr. Niranjan Saha, former Director WPDCL and Director GBS Energy Private Limited, and for his constant guidance to the organizers. Thank you all the enterprising and aspiring participants for sparing your valuable time in attending today's online seminar. We are sure the input received here will help you to shape up your future in a better way. And let me offer my heartiest congratulations to all of you. Our heartfelt appreciation to our anchors, Mr. Arno Banerjee and Mr. Anirban Dotto, for their meticulous planning and conducting the seminar. And my special thanks and appreciation goes to online coordinator, Mr. Pallav Adak, for his untiring and creative endeavors. Good job done, Pallav. Thank you once again. Namaskar and goodbye.
Thank you, Arno. Thank you, Arno.
So meeting ends here.
Thank you, everybody. Thank you, everybody.
Thank you.
Mr.
I think today we end here. However, we'll take it further forward.
We'll take it forward, definitely.
Thank you, Professor Mondal. We'll see you again.
Thank you very
Thank
much.
you, everyone.
Thank
Nice.
Thank you very much for all of you, all of you.
Yeah.
Nice.
Thank you.
Thank you very much.
Okay. Thank you.
Thank you. Thank you.